Hello guys, now we are going to discuss about one of the most important and most beautiful course of our network industry, which is named as CCNA. CCNA stands for Cisco Certified Network Associate, which will help you to improve yourself about network basics, switching, routing concepts, IPv4 concepts, IPv6 concepts, and so many things about it. Like for example, if you are a beginner for network technologies, then our CCNA certification program is great for you about your certification and providing you about job assistance. As well as this CCNA course, begin your career in network industry. Now what you will learn in CCNA course, you will learn about networking fundamentals, IP connectivity, security fundamentals, automation and programmability issues. So many things you will learn in this. And our A2IT's networking CCNA course, which is prepared by Cisco Network Academy instructor, it will cover all the topics that you need to prepare for 200-301 certification exam. And you can see the full list of our topic on our link, that where we have 6 main sections in this, as we have discussed: fundamentals of networking, routing, switching essentials, scaling network, connecting networks, securities, automation and programmability. Besides this, I just want to let you know about, we will provide you the access of our A2IT app. On the A2IT app, you will get extra study materials to learn about certification exam. Besides this, we have arranged the course like from basics to advanced level. Like we will start from the basics, like we will start from IP address, we will start from how to make design on Cisco packet tracer, what are the fundamental in this history. And also you will get the workbook of the practicals of all the CCNAs. In practical workbook of CCNA, you will get the latest design that is used in networking industries, as well as some big companies live architecture we have designed in that workshop. So enjoy learning and be safe. Thank you so much. Hello friends. So our today's topic is routers. As you see the image of routers here, these are the Cisco Catalyst based routers. We have so many routers: 1800 series router, 37 series router, 36 series routers. But actual question is, what are routers? What is the role of routers? Why we use routers? So many questions. So I will let you know about, this is a router. Routers are actually root devices. Now the root devices is like, it is used to define the path from one network to another network. For example, you want to transfer your data from Chandigarh to Delhi or in another network, so many locations. So you have to use a router. And in internet, it plays a very important role in this, because it is act like a dispatcher. Like you want to dispatch an information, so router will work like a dispatcher. So as we see that these are the hardware router here, and you are seeing so many ports here. There are so many ports here, and you can see there are auxiliary port. This is your Giga Ethernet port, this is your console port, and this is also your Giga Ethernet port. These are USB port. So each and every port has its own things. Like what is the role of each and every port? Let me explain. First of all, you can see there are Ethernet port. In some routers we have Ethernet port, like in 1841 router we have fast Ethernet port, and now you can see this router, it has Giga Ethernet port. Like Ethernet is the technology, like Ethernet is for 10 Mbps, fast Ethernet is for 100 Mbps, Giga Ethernet is for 1000 Mbps. So it is based on catalyst. No worry about it. Ethernet ports are actually used for LAN connectivity. Like you want to connect your router with one local area network with the help of switch, so you can connect it with Ethernet port. Okay, so Giga Ethernet ports are used for this. So these two ports are used for switch connectivity, you can see easily. And after that, auxiliary port meaning is if you want to connect modem with router, modulation and demodulation, it is used for converting the signal actually. So if you want to connect modem, then auxiliary port is there. Now you can see here console port. Now this port is same as Giga Ethernet, but console port is used for configuration of router. Like in CCNA, you have to work for so many practicals, routing, static routings, RIP routing, EHGRP, OSPF, so many things are there. So if you want to configure your router, then you have to connect it with console port. And at last you can say here EHWIC WAN interface card, like do not install interface card with power fit. So you can check here why we use this, why we use these cards here. Actually these cards are used for modular router, like you can extend your ports in that. Like for example, I want to connect this router is with this router. So we have two options. Giga Ethernet is with fast Ethernet, or you can do router to router one another port, serial port. Like in this module, that is this time it is closed, you can unplug this, you can add your serial module in this, and after that router to router is connected with serial port. So basically we have fast Ethernet, auxiliary, console and serial ports in our router. Thank you so much. Hello friends. So today's our topic is switch. So you can see the images of switch on my screen. After considering router that was used in WAN, we have to work on switch now. SWITCH, switch. Okay, so switch is basically a LAN device which is used in local area network, and basically it is known as like one port to another port device. One port to another port device. Like this is the basic example of this. Basically switch is used for transferring data within the LAN only, and we have so many catalyst switches are there like routers. We have 2950-48 port in which we have 2 GBIC. We have 3550 and 3550 power over Ethernet. So some switches are here layer 2 switch and some are here multi-layer switch. So 2950, we have another 2960s also, but within this image is 2950. Layer 2 switch and layer 3 switch. Layer 3 switch is actually known as multi-layer switch. Layer 2 switches are used for the LAN purpose, like within an intra area we have to connect our data. But multi-layer switch act like a router also. Yes, act like a router also, because multi-layer switch is working on data link layer as well as network layer, but layer 2 switch is only working at data link layer. So in layer 2 we can only specific functioning like VLAN, STP, port security, but in multi-layer switch we can do routing also. Like for example, in our router we don't have ports, or we have limited ports, so we can use multi-layer switch instead of router also. Now switch has one important thing. Switch is a smart device. Switch is a smart device. So switch first time do broadcasting. Broadcast means one to everyone. Broadcast means one to everyone. Like if I am connecting to this port, for example, this is my PC and this is my friend's PC, and we have so many friends here. I want to transfer data from this PC to this PC. So first time switch will do broadcast. Broadcast means it will send the information to everyone. And after that, when broadcast is done, switch make MAC table. Now what is MAC address? Media access control address. Each and every device which is going to connect with switch, like which is going for sharing the information, that has MAC address. Like my laptop has MAC address, my mobile has MAC address, So at that device which is going to connect with internet is that have MAC address, because MAC address is your identity, physical identity. It is 48-bit hexadecimal address. Okay, so switch learn MAC address of both the device. So that's why first time it will broadcast, after that it will go for unicast, like one-to-one process is done after the broadcast. Okay, and after that switches are of two types, manageable switch and unmanageable switch. Manageable switches are like which we can configure. Manageable switch are configurable switch, like you can configure anything. For example, VLAN, inter VLAN, okay, port security. You want to set up something, so you have to use a manageable switch. Unmanageable switches are those which are only used for sharing and internet connectivity. Like we cannot put specific commands on unmanageable switch. And the basic difference is manageable switch has console port like router. We have discussed about console port. Console port is used for configuration. One port is in the console port and another port is in the COM port of computer. Okay, so unmanageable switch don't have console port, so we are not able to configure unmanageable switch. So in real version, in the companies, mostly they will work on manageable switches for the security. Okay, and after that, if we know about like single layer and multi-layer, so we have already discussed layer 2 switch is known as single layer switch, and multi-layer switch layer 3 is known as multi-layer, because it is works on data link layer and network layer. Thank you so much. Hello friends. So today's our topic is about firewalls. Yes, firewalls. As we all know, firewalls are the security device in our network. So within our network component, firewalls are the very important parts, and there has a great key role in our network technology. So first of all, we need to know about this keyword firewall. So firewall is used for network security. Like for example, you have a network. Okay, so anybody can attack on your network virtually, because on physically there is a different things, but virtually some hackers and some script kiddies can connect your network. So we need to prevent that unauthorized access, so we need firewalls. So firewalls, we have Cisco firewalls, we have Fortinet firewall, FortiGate firewalls, we have so many firewalls. So basically firewall is used to prevent unauthorized access from outsiders. Like for example, one person working in intranet, okay, and it is also connected with internet also. Intranet means within an area, but I don't want that outsider can access my network. So that's why I will use firewalls in this. But in current version of CCNA, you need to know about it. We have basic firewalls as well as we have now next generation firewalls. Actually, next generation firewalls are our third generations of firewall. Third generation is like in the traditional perimeter security, we were using about gateway, antivirus, normal firewalls. We are going to connect with VPNs and web proxy, sandbox, SSL inspect. We have to do each and everything one by one. But in next generation firewalls, all parameter security now in a single device, because in which we have security rules option. And in traditional firewalls, we were working on like I want to like protect from virus, so I will install antivirus in this. I need IPS and IDS, intrusion prevention system and intrusion detection system. Like we have independent point solution in traditional firewalls, but in next generation firewalls we have inline deep inspection. Inline deep inspection. So we don't have to install each and every features in another like firewalls. We can easily put our normal normal device into next generations. So that's firewalls, web filter, web proxies, and so many things are combined into one thing. So our cost will be less, as well as our workload will be less. So next generation firewalls are the future of our network. Thank you so much. Hello friends. So today's our topic is about access points, server clients, and wireless LAN controllers. So as we know that about routers, switches, and firewalls, we have another network components like access points, wireless LAN controllers, and server client architectures. So first of all, we need to know about access point, like what are the access point. Actually, access points are used to connect multiple wireless devices with each other, like PCs, laptops, smartphones, mobile phones, so many things which you want to connect with like wireless system. It works same as hub and switch, but in hub and switch we are using cables to connect the devices, but in access point we don't need any cables or any device to connect your wireless devices with each others. Actually, access points and wireless LAN controllers use radio frequencies, like they are using radio frequencies. With the help of radio frequencies, you can connect another devices with each other. But within wireless LAN controllers, for example, two users, Rick and Donald, are connected with this access point. Okay, with the help of wireless LAN controllers, it is your choice. You want to connect with these connect with each other. They will connect with each other, or they will not connect with each other. So you can connect. You can control your wireless design. On the other hand, we have servers and clients. These are the devices like computers. In server client architecture, there is a domain network. Domain network means like within one premises, within an area. Okay, like one person is like the admin in this, and every person is like the peer-to-peer network. So that's why in server and client architectures, we have another, every other PC is working like a client, but the PC is working as a server which has centralized network control. We have server PCs have centralized network control, and with the help of this centralized network control, server can set permission to every client within that network. So server is very important. Same as within access point we can make securities, but in server LAN network security is more powerful than access point security. In access point we can also make securities, we can put securities, but in servers we have great centralized control. In router we have so many securities, like in access point we have basic security. It is working like a bridge actually. So access points are used to connect another various wireless device with each other. Wireless LAN controller same working as like this, and server is working like a domain controller, like domain network. Within that, endpoints and servers are connected with each other. Okay, thank you so much. Hello friends. As we have described the network component, so our another module is network topology architecture. So in our network topology, we need to know about our way of connection of network devices. So today we are going to explain about network topology architecture, in which we have to discuss about two-tier architecture, three-tier architecture, and after that spine leaf, WAN, and so many architectures. So we have to start with the topic with two-tier architecture. So as you see, there are the image. There is an image of like core and distribution layer and access layer here. So you can check this one. These are the core and distribution layer, and this is the access layer. This is two-tier architecture. Okay, first of all we need to know about two-tier and three-tier. What is two-tier and what is three-tier? So in computer networks, CCNA networks, or campus network design, we have three layers. One is access layer, one is distribution layer, and one is core layer. But these layers are divided into two parts. Like if access layer and core plus distribution layer are connected directly like this, then this is two-tier architecture. But if our distribution layer is like connected to access layer, and our backbone, if we connect our multi-layer switch or our extra routers here, and these are also directly connected with this, then it becomes three-tier architectures. Okay, now first of all we need to know about what is access layer. So access tiers provides connectivity for the end users, etc. End users, we need to know about the end users. Like we need high port density in this, like our PCs, our computers, our printers. These all are connected with access layer. Okay, and after that access layers, you can see access layer switches are not directly connected with each other. Why? Because at access layer there are some security issues. So if we have security issues, then access layer is directly connected with distribution layer. Okay, and after that this is like two-tier. First of all we need to know about distribution layer. Distribution layer here, like we connect with this, this and this, like this and this, like we can connect like this. Distribution is responsible for connecting access switch together, like switch 3, switch 4 and switch 6 are there. So we are not able to directly connect access switches, so we have to connect with the help of R3 and R4, switch 3, switch 4 and switch 5. Like if you want to do the practicals of VLANs, inter VLANs, then you can go for the distribution layer. Now I have mentioned here, like this is core and distribution layer. So this is the two-tier. But if I remove this core part from here and I will add here like one more switches, backbone and core routers are there, like this. The connectivity is like this, directly connected to this. This one. You can see now distribution layer is, I am going to connect this is also with this. Like there are so many redundant paths. Redundant path is used for the duplicacy. Okay. So I will connect this. Now distribution layer is going for connect switches with each other, and core layer is directly connected with now core tier. What will do the bit with the core tier? Core tier will connect the switches together. This is a third level of hierarchy. Before that we were working on, so this is connected. This one is connected with R3. Okay, now we can see if anything is misses, then don't worry about it. Access layers are not directly connected with each other with the help of security issues. Distribution layer is going to access with switches, and switches are connected with the help of distribution layer. And after that the two ether switch router I have connected here, and this is your third level hierarchy. You can say third level hierarchy. And so the reason is what is the main responsibility of this layer? So the main responsibility of this layer is route traffic. Like the route traffic as fast as possible over multiple redundant path is the meaning of core layer. So this is the example of two-tier and three-tier architectures. Thank you. Hello friends. So in our last lecture we have discussed about access layer, core layer and distribution layer. Like we have discussed about two-tier architecture and three-tier architecture. In access layer, distribution layer and core layer we have discussed about so many things. Now I want to let you know about the new technology, network topology architecture which is known as spine and leaf architecture. Spine leaf architecture. So in this, first of all, I need to delete this cable, these devices, and I just want to show that spine leaf architecture, spine leaf. So in spine leaf architecture, what we can do, actually in core and access layer and distribution layer, devices are connected like access to distribution, distribution to core. In spine leaf architecture, spine leaf, each and every device is directly connected to each other. Like we have to connect these two switches, three switches are also with each other. Like when R3 is connected to switch 1, R4 is connected to switch 2, switch 5, and these are also directly connected with each other. Now, access layer actually known as leaf, and now we are not saying it as a distribution layer, we will write it as spine. So this is known as spine leaf architecture. It is consist of two layers, leaf layer and spine layer. In this topology, each and every device is directly connected with each other. We call this as a switch fabric. Okay, so in this design, access layer is known as leaf layer and distribution is known as spine layer. Actually, why we use this architecture? Actually, we access with the core layer, distribution layer and access layer. So distribution layer is basically used for VLAN, inter VLAN and so many things. Actually, for example, we have one switch has 4 uplinks. Each link has your 100 Gbps connection. Okay, so if 4 connections are connected with each other, then it will provide you 400 Gbps uplink bandwidth. It is used for uplink bandwidth. Like if we are consuming 100 Gbps connection here and we have four leaves, each leaves have 4 uplinks, then it will provide us 400 Gbps connection. Okay, so this is the benefit of spine and leaf. Actually, this topology is taken from core, distribution and access layer. So it is just the rephrasing of the name. Thank you so much. Hello friends, as we have discussed about our network topology architecture, like 2-tier architecture, 3-tier architecture, spine leaf. So we have one main network topology architecture which name is WAN. Which name is WAN, wide area network. So we know about WAN. WAN is wide area network which is used to connect to different networks with each other. Like with the different location we can connect with the WAN architecture. So we have so many WAN design we need to know about. First of all, what are the network topology designs in WAN? So first of all, the first design in WAN is multi-access WAN. Like this is the WAN. In this you can see there is a cloud, like we can take it as a cloud, like not a cloud, it is like an internet service provider. So with the help of this service provider, we can see this is our router on different location, this is our router and this is our router. Okay, now this service provider has multi-access link with all the 3 networks, and after that these router will provide the information to switch and another access layer device, switch and another access layer device. It is known as multi-access design. But for example, you don't want to use multi-access, then in second design you can also use point-to-point architecture. What we have to do in point-to-point architecture? In point-to-point architecture, the design should be this. Like I will show you with the design. In point-to-point, we are not using any multi-access network. We will directly connect with this R7 to R9 and R2 like this. This is your point-to-point network, because in this network R7 is directly connected with R8, R8 is directly connected with R9 and R9 is also directly connected with R7. So we can use multi-access network as well as we can use point-to-point network. Now, multi-access network, we have some types, like we have layer 3 MPLS service. We will discuss about it, multi-protocol label switching. And after that you can use it as a layer 3 like multi-protocol label switching, one node directly connected to another node with the help of multi-access. Okay, so this is the example of MPLS. If we considered it as a layer 2 like VPLS we can use, or Metro Ethernet you can use this layer 2, or we can use it like a frame relay or ATM technology. So what we have to do in layer 2 WAN, this type of design, this will use same network ID, like it will work on same network ID architecture. But in layer 3 MPLS it will work like a different network ID architecture, and after they will provide their internet, their WAN to another information. Okay, like in frame relay we all know about it. Frame relay, what we have to do in frame relay, like it is different. Frame relay architecture is like a packet switched technology. Packet switched technology means it is not connected with 1 to 2, it is connected with DLCI information, data link connection identifier. But in frame relay there is one simple there is a small problem in which you are not able to get the direct bandwidth from your service provider. In frame relay your connection will always establish with the help of DLCI. Okay, your like you can say switched virtual network and permanent virtual networks are connected with each other, but you are not able to get direct bandwidth like MPLS or their WAN design, another WAN design. So frame relay is your cheaper design. So these are all the network topology architecture. So I will rewrite it, like first of all MPLS design you can use. After that multi-access we have discussed, you can get point-to-point WAN also, and after that you can get frame relay WAN design. Thank you so much. Hello friends, we are again going to discuss about network topology architecture, as we have discussed about 2-tier, 3-tier, spine leaf and WAN design. So we have two topics like which is also going to implement in network topology. One is SOHO architecture and one is on premises versus cloud architecture. On premises versus cloud architecture. But first of all we need to discuss about SOHO architecture. Actually small office home office design is basically used to reduce the devices in our topologies. Like we know that we are going to connect with internet service provider with our routers. Router is connected with our switch. Now switch is connected to your PCs in your small offices or home offices, and after that you can connect it with printers. You can easily connect it with printers. Your PCs are easily able to ping with each other. After that switch is going to connect with one access point, and access point basically use here to connect those devices which is not able to connect with your WAN, like your cable design. So like my mobile is not able to connect with cable, RJ45 connector is not going to put into my mobile, so that's why I can use access point here. You can connect with your laptops, you can connect with your smartphones, you can connect with your tablets. So anything which is going to connect with like within one premises, that is called SOHO design. And one more topic that is pending in our network design, that is on premises versus cloud. Like we are discuss about the WAN architecture. Like in WAN we are working on data centers. Like data centers are the servers, like your routers and switches are going to connect with each other with the help of data centers. Actually data centers traditionally host centralized infrastructure. Like if we talk about our data center, so data center hosts centralized infrastructure. This centralized infrastructure known as on-premises cloud. On-premises cloud. Sorry, on-premises. Okay. But in this time, public cloud offering gained popularity because we don't need to set up all and everything in our systems or in our space. So if we discussed about cloud, so now it is gained so many popularities compared to like on-premises or centralized infrastructure. You can say centralized infrastructure. In this, we don't have to shift our workload, our system, our devices to one space to another switches and another spaces. We don't need so many space here. We don't need any square foot areas. In cloud architecture, we just find scalability with no area. So if we find scalability with no area, then cloud option is popular than on-premises. Okay, so this is the SOHO architecture and this is the difference between on-premises versus cloud architecture. Thank you so much. Hello friends, our today's topic is about cables. Cables are known for shared media in our network. After working on network components, we need to know about how our data share from one location to another location. Okay, so we need to know about our cables. So first of all, we need to know about coaxial cable. We have another cable also here, like fiber optical fiber as well as twisted pair cable. So many cables are there. But first of all, coaxial cable. In coaxial cable, we need to know that how it is stimulated. First of all, coaxial cable is shielded with plastic cover. After plastic cover, we have one insulator in that. And after that, we have outer conductor shield, insulator and our main inner conductor. With the help of this inner conductor, we can transfer our data from one location to another location. And basically coaxial cables are used for, like you have seen the telecommunication media. Most of the time this cable is being used. And after that, after coaxial cable, we have another cable which name as fiber cable, the one of the fastest cable in our industry. Fiber cables are used to transfer data within milliseconds, nanoseconds, and these are much more expensive than coaxial cables. But in fiber cable we have two types of mode: single mode fiber cable as well as multi-mode fiber cable. Now what is the difference between single mode cable and multi-mode cable? Actually, fiber cables carrying with a small light in their cable, and after that we need to know about it has 9 micrometer in diameter and multi-mode is 50 micrometer in diameter. So if we have more diameter in my cable, then it means we have a larger core, and larger core means we have multiple modes, so we can send our data from one location to another locations very fast. And after single mode and multi-mode cable, we have twisted pair cable. Twisted pair cables are like, this is the cable and they are twisted with each other like this. Twisted pair cables are basically the LAN cables. LAN cables are basically used in our companies if we want to connect our data with access layer like laptops. We can connect our data with laptops, with PCs, with server and printers. Thank you so much. Hello friends, our next topic is twisted pair cable. In last topic we have discussed about single mode fiber, multi-mode fiber and copper cable. And we have discussed about twisted pair, that twisted pair cables are twisted with each other. But actually twisted pair cables are divided into two parts, and the parts name are straight cable and cross cable. Straight cable and cross cable. And now you are watching the screen and you can see there are different color coding cables are there, but it is not the big deal. Actually these are not the colored cable. We can make these in any cables, like this is the manufacturer cable. Actual difference between straight cable and cross cable is this: straight cables are used to connect different devices with each other. Different devices means, like if you want to connect with your PC to switch to router, okay, and after that switch to server. Straight cables are used to connect with different devices, and cross cables are used to connect with same device. Now what is the meaning of same device? PC to PC, switch to switch and router to router. But the question is how we can make cable. How we can make cable here. So I just need to let you know about it, that how we can make this cable. So we have basically a color coding. So we need to know about this color coding. Okay. First of all, we need to know about straight cable. Okay, even it is straight or even it is cross. Okay, we have 8 types of cables here. 1, 2, 3, 4, 5, 6, 7, 8. On the one hand, first cable is orange, white, orange, green, white, blue, blue, white, green, and brown, white, brown. Now, for example, this is your one end of cable. This is your one end of cable. After this video, I will let you know about the practical cable making practical. We will make straight cable as well as we will make cross cable also. So this is the one end of straight cable. Now, how it will become straight cable? If both end have same configuration, orange, white, orange, green, white, blue, blue, white, green, and brown, white, brown. So if both end have same type of cables, then this is known as straight cable. As I already told you, straight cables are used to connect different devices with each other. Now, on the other hand, we have cross cable. Now, cable is same. Now, many students ask the question about, sir, cable is different or cable is same. Cable is same and the one end is also same. Orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. As we can see, we have just made this cable in straight. But in cross cable, we have one basic formula like 1326. Some people using 1236 also. It is based on the company. So what is the meaning of 1326? So basically I am using in my company 1326. 1326 means first cable is replaced with third and third cable is replaced with first. So green white here comes at first place and orange white comes at third place. Second cable is replaced with 6 and 6 is replaced with second. So green is here and orange is here. Like on the one hand you have to use this coding, on the other hand you have to use this coding, right? Blue, blue, white, brown, white and browns are at their same place. So this is the symbol of cross, so that's why we named it as a cross cable. Cross cables are basically used for same device connectivity. Thank you so much. Hello friends, now we are going to discuss about practical of straight cable and cross cable, because in last video we have discussed theoretically about straight cable is used to connect different device with each other and cross cable is used to connect same device with each other. So in diagram we have seen about these cables. This is our LAN cables. This is of yellow cable, this is of blue cable and some are of our gray cable. So don't worry about this part of cable. You need to know about the connections of cable. So on the screen you are seeing orange, white, orange, green, white, blue, blue, white, green, brown, white, brown. So now we are going to make practically this cable as a straight cable. So first of all, for straight cable we need a LAN crimping tool. So this is known as a LAN crimping tool. It is used to cut the cable, it is used to crimp the cable, and basically it is not used only for RJ45 connector. In telephone wire you have seen RJ11 connector. So this LAN crimping tool is used for same purpose also. So I am going to cut this cable. This is already made cable and this is one time use connector. So I am going to cut this. So now my cable is this. After that I have to peel the outer part. So after peeling the outer part, you can easily see there are twisted pair cables. So I told you in last video, this is known as twisted pair cable because the cables are twisted with each other. Now we have to open these because we have twisted. So if we want to make this cable as connector free, now after this we have coding orange, white, orange. blue, white, blue, green, white, and green and white, brown. So first of all, orange, white, you have to take one by one cable, orange, white, orange, green, white, and after that blue. These are very small cables. Blue, white, and green, and brown, white, and brown. So you have to straight these cables. After straightening these, we again need LAN crimping tool. Now we have to equally cut the top end of cable, because we don't need like this is done the fluctuations way, we need it straight way. So now you can see these are equal. Now we need RJ45 connector. I told you in last video also, RJ45 connector is used to connect laptops, PCs, printer, and RJ11 connector is used for telephones, like landline telephones. So again I have to just cut this. So just make sure your cables are straight, and we have to put RJ45 connector in this easily. And one thing you have to make sure, in your left side, like my left side is this, your left side your orange white should be there, and the top of the right side your brown should be there. So you have to make sure your cables tops are connected with the edge, and after that it is the time for crimping. So after crimping, you will see little bit about tick, and if you want done it with this, now you can see the cable is done. Now on the other hand, already I have made previously with this cable. So this, if you are seeing that both the ends are same, then this is the example of straight cable. Straight cables are used to connect to different device. Now I will cut the other end of cable. Okay, now I have only this end. If I will use this connector same as here, it is become straight cables. But now I'm going to peel. I want to show you about cross cable. Cross cables are basically used for same devices. Like I want to connect my laptop with my company PC, as well as if you want to connect switch with another switch, and if you want to connect your router with the routers, then we have to work on cross cable. So what we have to do with cross cable, it is also very easy. Okay, now we have to follow 1326. In last video we need to know about cross cable means first cable is replaced with third cable. Like at this type, first cable is orange white. Now orange white is at first place. Now we have to replace it with third cable. So first is orange white, you can see in diagram also, orange white orange, green white blue. So green white will be at the first place, and second cable is replaced with 6. So green should be on second place, and then orange white, blue, blue white, and at 6th place your orange will be there. So brown white and brown. Again the process of making cable is same. Again cut the top edge of the cable. After cutting top edge, I am taking again RJ45 connector. After RJ45 connector, again we need to make sure that your cable ends are connected at the top of the RJ45 connector. So if they are connected with each other, now the cable is done. Now this cable is known as cross cable. So if you want to test this cable, then we have a LAN tester also. So we have to put it into the end of LAN tester. Yes, it is done. If you are seeing that first light is blinked with third, and second light is blinked with sixth. So it is known as cross cable, and it is very fast cable right now if we connect for PC to PC connection. And I already have straight cable. If you will check straight cable connection, then what will happen? Then the happening is 1 to 1, 2 to 2, 3 to 3, 4 to 4, 5 to 5. Okay, so this is the practical of straight cable and cross cable. Thank you so much. Hello friends. Today I am going to discuss about one important concept of our network component and our shared media. The concept of PoE, power over Ethernet. In last video we have discussed about switch, that switches are of two types, manageable and unmanageable. After that, manageable we can manage that switch, unmanageable we cannot manage. And after that we have discussed about our single layer and multi-layer switch. But now I am going to discuss about power over Ethernet technology. This is my power over Ethernet switch. Now first of all, what we need to learn about power over Ethernet? Actually, it is a technology in which your network cable carry electrical power. So you do not need any electrical power for next connection. PoE switch helps you to connect your network cable carry with electrical power. So I just want to tell you about with one example. You can see here there is power outlet, and after that power outlet is connected with UPS. UPS is connected with switch. Now this is power over Ethernet switch. Now power over Ethernet switch connected to wireless access point, Cisco IP phones, video surveillance camera, like so many devices we can connect with this. Now I just want to take an example. The example is, for example, this is a digital security camera. Now this security camera requires two connections to be made when it is installed. Like first, network connection. Why we need network connection? It is needed to communicate with video recording and display equipment, like you can see on this design. Okay, after that, this video surveillance camera also need what? Power connection. Now if it is need power connection to deliver electrical power, the camera need to operate. Now with the help of PoE enabled switch, only network connection need to be made, as it will receive its electrical power from this cable as well. I don't need extra cable to connect with electricity. So this is your power over Ethernet connection. Power over Ethernet. Now you will think that what is the benefit of PoE? Why it is used? So first of all, PoE is time and cost saving. You can say the benefit, time and cost saving. It provides you flexibility. It provides you safety, and also provide you scalability. Like you want to extend your network, so it provides you scalability also. So power over Ethernet technology is the future of our network. Thank you so much. Hello friends. In our last video we have discussed about cables. We have discussed about single mode fiber, multi-mode fiber, coaxial cable and twisted pair cable. But today we have to discuss about the cable issues, like we have to identify the collisions, error, duplex, speed mismatch. These are some issues when we transfer data from one interface to another interface. Then there are some cable issues, so we have to discuss about it. Now you are seeing there is a switch, 3560G PoE switch is there. For example, you are going to connect your PCs with this switch. And for example, this is your APC, BPC, C and DPC. Now A want to send data to BPC. Then what can be the issues will be there? First of all, there will be the issue of collision. Now what is collision? Actually collision is a mechanism. Okay, it is a mechanism which is used to control the access by given the bandwidth. Like somebody, some service provider accesses, provides the bandwidth, and collision is a mechanism which is used to access the bandwidth as well as access. So this is the first issue in our network. And sometime when we used to send the data from switch, as we know, switch works on data link layer. Switches are the device which works on data link layer, and data link layer is the layer which is used for error detection also. Sometime when we discuss about OSI model, then we need to know about error detection is placed at data link layer and error correction is at transport layer. So for detecting the error, switch use the concept of cyclic redundancy check and frame check sequence. Okay, in this frames, when the data comes from network layer to our data link layer, then there is one header and trailer attached to data link layer, in which when one PC want to send data, I will clear it. When A PC wants to send data to B PC, then with the network header like packet, it sends header of data link layer, trailer of data link layer. After that, when it sends the data A to B, it sends one CRC value. CRC value, for example, it is a number. For example, A sends the CRC value 3030, and when it receives on B, if the CRC value remains 3030, then there is no error. But if the value is changed here, for example 2030, I'm just taking an example. If number is not matched, then there is a error. The another issues in our cable interfaces, duplex and speed mismatch. Okay, first of all we need to discuss about duplex. Duplex means you can transfer your data in both the direction. Yes, we have discussed before that duplex is of two types, half duplex and full duplex. Half duplex and full duplex difference is, in half duplex you can send your data at one time to receiver, and receiver can receive at single time. When receiver becomes sender, then sender becomes receiver. Like we cannot data simultaneously at one time, but in full duplex we can send data to one interface to another interface at the same time. And sometime in the cable duplex will mismatch. Like for example, I'm taking a router is connected to switch, and this is fast Ethernet port. Okay, and this is switch, this router is connected with another router with fast Ethernet port. For example, here I'm using half duplex, here I'm using full duplex. So there will be some errors also. So speed may be mismatch. If you want to see practically, then I will show you. I have to use here Cisco packet tracer. I will raise it. For example, this is connected with this. Okay. I will let you know about this software Cisco packet tracer as well as GNS3. I'm just letting you know about show run command. In show run command, when you will check at interface fast Ethernet 0x0, you will check duplex is auto, speed is auto. Okay, I'm just giving one IP address to this. We will discuss about IP address later in the video. So here I'm just using, for example, I just want to show you about it. So no worry about IP address. Okay, so when you go for FA0x0 link, then you can check speed. For example, I'm giving speed this to 10 Mbps, then speed, it will check the speed with 10 Mbps operations. If I will give speed 100, then it will give 100 Mbps maximum operation. But this is a switch. Okay. If any router connected to its interface, for example, I will delete the switch and any other router. This one. And here F0x0. Okay, I will just do it on it because this is a simulator. I don't need IP address here. For example, on this interface I am using speed 100, and on this interface I am using speed 10. So there may be some errors here. So, and also here duplex, if at one side duplex is full and another side duplex is half. then there must be a problem. There will be a problem here. Okay, so these are the cable issues that we have discussed today. Thank you. Hello friends, today we will going to discuss about TCP and UDP. So in our last video we have discussed about cables, 2-tier architecture, 3-tier architecture, but the important things are protocols. As we know that protocols are the set of rules for communication. Protocols. So we know that these are the set of rules for communication, like we want to send our data from one interface to another interface or one location to another interface. So we need protocols. So we have so many protocols, like in OSI model we have layers: application, presentation, session, transport layer, network, data link and physical layer. But nowadays we are not using OSI. OSI is just reference model. We are using TCP IP model. So according to TCP IP model, these application, presentation and session layer converted into application, after that transport, after that internet layer, and the last two layers are divided into network access. So the one thing is common in both the models, OSI and TCP IP, is transport layer remains same. As we know that on application layer we have so many protocols: HTTP, FTP, DNS, DHCP. But how these protocols are divided? Like, so we have to know about it, how these are divided. So these all protocols are divided into two parts: TCP and UDP. So what is TCP? TCP is transmission control protocol and UDP is user datagram protocol. Okay, now what is the difference between TCP and UDP? Actually, TCP is our connection oriented protocol and UDP is our connectionless protocol. Now we need to verify the difference between connection oriented and connectionless. Okay, I will let you explain. Connection oriented is, for example, I want to send data to any person, and after sending data, for example, this is my location, okay, and this is another person location. I want to send data to PC A to PC B, and in TCP connection, first it will verify the path, like path is clear or not. After that it will get acknowledgement from the destination, like we can talk or we cannot talk. And after that I will send the data. So if we easily understand this, in connection oriented we will get the acknowledgement from the destination. In TCP the connection is reliable, like we can accept updates easily, but TCP connection is slower than UDP, because first it will check the path, after that it will check the acknowledgement, and after that it will send the data. Like in TCP we have three-way handshake process. On the another side, I will give you one example again. For example, I am working in a company and tomorrow I need a leave and I need to get permission from my managing director. Okay, so first of all, I just want to say, I will not say directly to managing director, sir, I need a leave. First of all, I will go to my director, sir. Okay, I will go to my director, sir, and I will say, sir, I need to talk about something. Okay, and then if my managing director is free, then he will say yes, otherwise he will say no. Okay, so if my managing director will say yes, then it means one message sent by me, second message sent by my boss, and third time I will send, sir, I need leave. Okay, I need leave, like I have to go to marriage of my cousin, like something. Okay, so this is called three-way handshake. But in UDP, there will be no three-way handshake. Okay, I will just clear it again. So it is connection oriented, it is your connectionless, and TCP use port number 6 and UDP use port number 17. UDP is faster than TCP because there is no acknowledgement in this. It will send data. If it will reach, it's okay, otherwise it is error. And it is unreliable, but it is fast. Now what are the example of TCP? TCP examples are HTTP and FTP and SMTP. HTTP is hypertext transfer protocol. For example, you want to like open your website, okay, like www.facebook.com. So with the help of HTTP, it will send the data to server. It will received by port number 80, and after that it will get reply back, and then it will open. Similarly, in FTP 21 port is used and SMTP 25 port is used. So these are connection oriented protocol. But is the example of UDP, DNS, DHCP, TFTP. It use 53 number port, 67, 68 port, 69 port. DNS is used for IP to name. DHCP is used to resolve. DHCP is used for providing IP address automatically, and TFTP works same as like FTP transfer the data from one interface to another interface. It is used in internet connection. So TCP and UDP has important role in our networking. Thank you so much. Hello friends. Today we are going to discuss about IP addressing. As we know that we have started with our work with network fundamental, and we have done with router, switch, topologies, architectures, so many things. So today's topic is about practical. But before starting the practical, we have to know about the simulator that we are going to use for practice. So the simulator name is Cisco Packet Tracer. As you are seeing that on screen, this software name is Cisco Packet Tracer. This is the software which is provided by Cisco, and it is totally open source software. It is free of cost. You can download it from Cisco's website. There are so many Packet Tracer website, and it is official software of Cisco. In the Cisco software, you can make design of your network. You can give IP addressing to network. After that, you have to go with routing technique, switching technique, security technique. So many things are there in this. So okay, let me start with the introduction with Cisco Packet Tracer practically. Okay, so in Cisco Packet Tracer, you will need to know that we have so many series of network devices here. Here you can see there are routers. Different catalyst based information routers are there. 1941, 2901, 2911. After that 89 series. CGR routers also, ISR routers are also. And in the switch section, here you are seeing switch. We have 2960 layer 2 switch. Some generic switch which are empty. You can add ports here. After that, this is multi-layer switch. This is also multi-layer switch. This multi-layer switch has fast Ethernet port, and this multi-layer switch has Giga Ethernet port. Another, we have hubs. Wireless devices are also there. Cell towers are also there. So we have so many devices are there. After that, if you want to work on cloud, then you can use cloud purpose. In configuration, we have DSL cable, frame relay, so many things. If you want to go for PCs, we have PCs, laptops, servers. This is printer, IP phones, VoIP phone. So this software is a like combo software in which you can go for every network device and you can make their simulation, because it is not able to get original router. These are so they are so costly routers, like it is not easy to purchase each and every router. So Cisco provides a software like Cisco Packet Tracer, so network students can practice their topologies on this. And also there are some features of Cisco Packet Tracer, like you want to write something, then sticky notes are there. You want to make any diagram of their topology, then this is also used. After that you can make changes with the diagram with this option. This is simple PDU. When we will configure our IP addresses on PCs and routers, then we can use this for pinging purpose. Like if in simulation purpose, you can ping this. After that we have another options like for example, I am taking one router here. Any router you can take. This is basic router 1841. So you can check here, this is the actual diagram of the router. You can on and off the router. After that you can add any port, like for example you want to add switch ports are there, then you can add switch port. Okay, if you want to connect router to router, then you can add serial port here. Okay, so in CLI portion we have to discuss about the coding, so coding part we'll do later. After that you can see these are the font of the coding part. So in options, preference, you can choose the font level according to you. If you are choosing 16, then the font size are great. If you are choosing different like 8, 9, 10, like it is according to your need, you want to change the font size. After that you can check in preference also. If you want to see the animation, you can use show animation. You can go for play sound also there. Show device model name, like device model name is 1841, you want to hide or you want to see. Show device label, device name label, like router 5, router 6. If you want to disable auto cable here, then you can disable this. So there are so many things basic. When we do practice, then day by day you will learn about it. Okay, so in cable part we have discussed about straight cable, cross cable. So if we are going to make topology here, okay, so first of all how to delete this, then we have a cross button here. So cross button is used to delete the component. For example, you want to make design like this, okay, router to router. So I told you that in router you can switch off the router. Then you can add HWIC2T port here on, and on another router you can also add HWIC2T port here. For example, you have not add port in this router. So when you will click on cable connection, then you will find console cable, straight cable, cross cable. After that fiber cable is also here, serial cable. So router to router HWCIT2T port means serial cable can be connected. But on this router serial port is not there, so you can connect router to router with cross cable also. This one. And if you want to connect router with switch, okay, then your straight cable will be used. And if you want to connect PCs with switch, then again straight cable will use. Fast Ethernet. Okay, so this is the designing part. So first we want to start with practical of IP address. Then before IP address you need to make about design. Okay, so in the next video we will discuss about IP addressing on my PCs and also IP address with subnetting part. Thank you. Hello friends, today we are going to discuss about again Cisco packet tracer, because in last lecture we have discussed about only Cisco packet tracer, like what are the options in Cisco packet tracer, how we can write image, how we can use sticky notes, how we can make a design. So in today's part we have to discuss about some basic commands that we have to use in CLI. So first of all we need to know about the modes of router. Before practical work on Cisco packet tracer, we need to know about the modes of router. So when you are going to start router, so I am using one router here. For example, I am using 1841. I will click on CLI. So in CLI, first time it will boot, and after that it will ask from you, would you like to enter initial configuration dialog? So you have to put no, because we have to do all the things manually. So I'm going to change the font size like on 14, it may be good. So this is your router. So here you can see the mode router. In this you can see the router looks like this. So this mode is known as user mode of router. In Cisco packet tracer we are finding. In original also it is using like this. Okay. Wait. So this is your mode. Now if I put here basic command enable, then you can see the router is changed. The router mode is changed from this type to this type. So this is called privilege mode, and you can call it as enable mode. Like you have to use one command enable here. Okay. After using the enable command here, I have one more basic command here, configure terminal. If I will use this command configure terminal, then routers looks like this. So these are the basic three modes. First mode name is user mode, second is enable mode, and last is global configuration mode. So the basic configuration of router and Cisco packet tracer is same for every practical. For IP addressing, for IPv6 addressing, it is same and it is equal. So we have basically three modes of router. One mode is user mode, and after putting enable command, second mode is privilege mode, and last is global configuration mode. So global configuration mode is used to do for all the configuration of router. So first of all we need to find basic commands of Cisco routers. So I need to have notepad. So in enable mode, which type of commands we can use? So I am going to explain you about basic commands. Okay, so I am just using 5 to 6 commands here. Okay, the first command is show run, and you can call it as show running -config. You can write it like it as. You can use show run or show running configuration. This command is used to see all the running configuration of router, like what is the original configuration on router. If the router is old router and we have some configuration, so we have to find all the configuration with this command. And if anything is saved on this, then the command is show startup config to see the saved configuration. Okay, one more command write is used to save the data. Show startup config is used to see the saved configuration, but for saving we have to use write command. I am using these commands in enable mode only. Show IP route. Show IP route is for to see the routing table. Like after that we are going to configure routing, so I have to use this command. Show IP interface brief. It is used to see interface information, like which interface is assigned with that IP address. And after that, if you want to delete all the configuration, erase startup config is there, and after that you have to use command reload. And there are so many other commands are there. Show history is there if you want to see history. Show clock is there to see the time. Clock set is there to set the command. So one by one, when we are going to do some practicals, I will let you know and explain each and every command of router. So after this, just try to move on to Cisco packet tracer. So this is my router. I just want to let you know about basic mode commands. So I'm using exit here. This is enable mode. like show running config. This is used for all the running configuration of router, like this. All the running configuration, and now no person has saved any data on this. So if you are going to use show startup config, then there is no startup config. But if you will choose write command here, then in show startup config you will get the command of show running config. The same thing that you have seen in running configuration, that is going to saved into NVRAM to RAM. So it is in startup config. And if you want to see the history of command, then show history is there, like how many commands I have used before. Show IP interface brief. It is used for brief information of interface, like interface is down, protocol is down, IP addresses are unassigned. Show IP route is for routing table, but this command we will show you when we have configurations of the router. So in next video we will discuss about the design of IP addressing. Thank you. Hello friends. Our today's topic is about logical address of networking, which name as IP address. So today we are going to discuss about what is IP address. But before IP address, we need to know one more topic here, which name is LAN and WAN. Like what is local area network and what is wide area network. Okay, so I'm going to start with the local area network first, because in both local area network and wide area network we are going to use about IP address. Okay, LAN means if devices are connected with each other with same network IDs. Like for example, we have two devices and they are connected with one cable, then they have same network ID, it means they are LAN. Wide area network means if devices are connected with different network ID and another device named router is being used here. So the difference between LAN and WAN is LAN is used for small area purpose and wide area network is used for like worldwide connectivity. In LAN, devices are with same network ID and switch or hub are using in this LAN device. But in wide area network, router is used with different network ID. So first of all, we need to know about what is a network ID, because with the help of network ID, we can make LAN and WAN. So network ID is a part of IP address. It is a part of IP address. So our today's topic is IP address. Okay. So IP address is Internet Protocol address. We have two types of IP addresses are there, IPv4 and IPv6. But today I am going to discuss about IPv4. After topics, we will discuss about IPv6. IP address is your unique address, as well as it is in the form of decimal, because computer supports decimal language. But on the very start we have discussed about computer, that computer is an electronics device which works on 0 and 1. 0 and 1 means binary. So all the addresses are at very first space, these are in binary format. So same as IP address is 32-bit address and we have divided it into decimal address. So the company which standardized the IP address is named as INA, Internet Assigned Number Authority, and they have divided into 4 octet, like 8.8.8. part, and some part in this IP address is network ID and some part is host ID. Okay, so if we know about binary to decimal, let me start with one basic introduction about binary to decimal. Like for example, we have 32-bit IP address, then we can understand all bit can be 0, all bit can be 1, and some bit can be 0 and some can be 1. So 0 means 1, 2, 3, 4, 5, 6, 7, 8 dot. 1, 2, 3, 4, 5, 6, 7, 8. 1 2 3 4 5 6 7 8 and 1 2 3 4 5 6 7 8. 1 1 means 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, and after that 24 32. So some 0 some 1 means 0 1 0 0 1 1 0 1 0 1 0 anything. So if we want to get lowest IP address, then we are going for binary to decimal conversion of this bit, and if we need highest IP address, then we need to go for this address for binary to decimal. This one, binary to decimal. So if we go for binary to decimal of 0 address, then what would you need to learn about binary to decimal? Multiply. So each and every bit multiply with 2 raised to power 0, 1, 2, 3, 4, 5, 6, 7. Like these are the prerequisites of CCNA. You need to know about binary to decimal concept at the very first place. So 0 multiply 2 raised to power 0, 0, plus 0 multiply 2 raised to power 1, 0. So everything should be 0 here. So if 8 zeros of binary becomes 1 0 in decimal, so 32 0 means our first IP address should be 0 0 0 0, like this. This is my very first IP address in decimal. Okay, understand the concept. Now I am going to binary to decimal of 1 1 1 1. So you can check here 1 2 3 4 5 6 7 8. Multiply 2 raised to power 0, 1, 2, 3, 4, 5, 6 and 7. So 2 raised to power 0 is 1, 2 raised to power 1 is 2, 2 raised to power 2 is 4, this is 8, 16, 32, 64 and 128. And if we multiply 1 with 128, then same number will be there. 1 multiply 64, same number will be there. So when we add these number, 255 figure will be there. So if 8 bits becomes 255 in decimal, then the highest IP address should be this. 255, 255, 255, 255. So basically 0.0.0.0 is lowest address. 255, 255, 255, 255. This is my highest address. Like my range should be, my IP address range should be 0 to 255 only. But INA company divided, Internet Assigned Number Authority divided this IP address into 5 classes. Classes of IP address. A class, B class, C class, D class, E class. The range of A class is 1 to 126, B class is 128 to 191, 192 to 223, 224 to 239 and 240 to 254. So 0 is missing, 127 is missing, 255 is missing from the range 0 to 255. 0 is reserved for default route that we will discuss in default routing technique. 127 is your loop back address, like you want to ping with yourself only. For example, your PC wants to ping with your own LAN card. So we will ping with one command 127.0.0.1. Okay, 255 is reserved for broadcast. So it is reserved for broadcast. Okay. So now range, I will clear this and again watching clear range of IP address A class, B class, C, D and E. Like if any IP start from 1 to 126, it is from A class, 128 to 191 V class, 223 C class, 224 to 239 and 242 to 254. Okay. First C class is used as an IP address in our networking, like 1 to 223. D class is reserved for multicasting. It is not used for IP addressing purpose in our PC. E class is reserved for scientific research and recovery. So it is also used by the INA team. So we don't need to discuss these IP address this time. Okay. So we know that now IP address range, like our starting range was 0000 and highest range was this. But in actual, that the usable range of IP address is 10002 128.255.255.255. This is A class. 129.0.0.0 191, sorry, 128 here. Here I have to use 126. 128 to 199, 255, 255, 255. This is B class. And 192.0.0.0 to 223. These are the actual usable range in our PC. So if we are going to use D class, E class or loopback address as an IP address, it will be not configured. It will gives you error that 127 is used for loopback, 0 is not a valid entry, like this. So this is the valid range. So this is non-IP address. So this is IP address. In next video, we are going to discuss about subnet mask and fixed length subnet mask, because IP address is only a logical address of PC, but we have to make network ID and host ID first, and we have to create LAN and WAN. So we need to discuss about subnet mask in next video. Thank you. Hello friends. So in our last part of our video, we have discussed about LAN and WAN and IP address. Okay, so in last part, what we have discussed about, what is LAN, same network ID, what is WAN, different network ID, and we have discussed about IP address in our last lecture. So after the conclusion, we discussed about that A class is 1 to 126, B class is 128 to 191, C class is 192 to 223. Okay, so what we have discussed that A class IP addresses are 10002, 126, 255, 255, 255. But actual IP address 10012, 126, 255, 255, 254. Like these are the valid IP addresses. Same as for B class and same as for C class. But our topic is pending, that how we can represent it like a LAN, how to make LAN and how to make WAN. So with these range of IP address, we need to know about one basic concept, that IP address are not only a single part for communication. We need one more part of IP address with the communication, that named is subnet mask. Subnet mask. So if you will try to give IP address of A class to any PC, like you are going to give IP address to your LAN card, then you will check, then when you give A class IP address, then automatically this value will placed in subnet mask option. In B class 255, 255.0.0 will be there. In C class 255, 255, 255.0, this will be there. Like for example, here we have one PC. Okay, for example, this is Rajiv's PC. Okay, Rajiv's PC with connected with any other PC like XYZ. So Rajiv has given 10.0.0.1 IP. So automatically Rajiv will get 255.0.0.0 subnet mask. If Rajiv will give 172.16.0.1 IP, so it is in the range of B class. So Rajiv will get this subnet mask. And after that, if anybody use 200.0.0.1 IP, we know that it is the range of C class. So we will get this subnet mask. So this subnet mask is the like important part of our IP address. How? Because it has some key roles. What are the key roles? Because if we have subnet mask, then we easily divide from IP address that which part is my network ID and which part is my host ID. So with the help of subnet mask, we can divide this. Okay, let me clear this once, and I will write subnet mask again. A class subnet mask is 255.0.0.0. Okay, so first we have to see A class. So this is a range of IP address. So what is the meaning of 255 in binary? 1, 2, 3, 4, 5, 6, 7, 8. 0 meaning 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Done? So this is the meaning of subnet mask, that there are 8 ones and 24 zeros are in there in A class. Okay, so it means that on bits are in A class are 8 and off bits are 24. Similarly, if we give V class IP address 255.255.0.0, then 8 ones, 8 ones, 16 ones are in B class and 16 zeros are in B class. So this is the portion of A class. In B class, on bit are 16, off are 16, like both are same. In C class of subnet mask, this one 24 ones and 8 part of 0. So in C class, on bit are 24, off bit are 8. Now the important concept in this, if in computer language 0 known for off bit and 1 is known for on bit, then in network part, on bit represents network ID. On bit means 1. It represents network ID and off bit represents host ID. Okay, understand the concept. So if we check in A class, 8 bit are of network ID, 24 bit are of host ID. Like host ID means how many hosts can be used in this network. In B class, 16 bit is network, 16 bit is host. In C class, 24 bit are network, 8 bits are off. Okay, let me clear you here. So for example, if we are using subnet mask, like it is used to divide, like if anybody asks you from that why we use subnet mask if we have IP addresses, then subnet mask is used to divide network ID and host ID from IP address. How? Because in A class 8 1 and 24 0, in B class 16 1, 16 0, and in C class 24 1, 8 zeros. And 1 means network ID and 0 means host IDs. Okay, what is the meaning of host ID? Let me explain. Host ID means in A class 24 bits are host, means 2 raised to power 24 host we can use, approximately 16 million. It is not the exact value, like it is 1 crore 60 lakhs. Okay, 16 million. 2 raised to power 16. In B class we can use 65536 IP address. In C class we can use only 256 IP address in my class. So network ID and host ID like represents that A class, B class, C class have their exact value of host, like in one class how many hosts I can use. Now come to the main point. We have discussed about in IP address LAN and WAN. In LAN, the portion of LAN same network ID, and WAN means different network ID plus router. Don't forget this thing. Like if you have one PC connected to another PC, okay, for example this PC's IP address is 10.0.0.1, so it is A class, so it is my network part, because subnet mask is going to represent that 8 bit of IP address are network ID. If second PC have same network ID like 10 and host can be any, like both are from A class, if network ID is same, then this is called LAN. Even if you are using any B class IP 160.1.1.1, but subnet mask is this, so this part should be network ID. If you want to make this LAN, then your both 16 bit you have to be same and another bit you can to be different. This is called LAN. Same as for 200.2.2.2, so 255.255.255.0, this part is your network ID. Then on another side 200.2.2 should be same and host ID should be different. This is called LAN, local area network. And in WAN we have to say different network ID plus router is being used. So for example, we have one switch and we have 3 IP addresses are here, like 20.0.0.1, 20.0.0.2, 20.0.0.3. So we have subnet mask 255.0.0.0. So if my 20, 20 and 20 is same, it means this is my LAN. Like you can say LAN 1. And if you want to extend this, you can use switch also, cross cable, like 20.0.0.4. Even we have multiple switches, but my network ID should be same, it is again LAN. But if we have another switch that has like, for example, class is same, but IP address is 50.0.0.1, 50.0.0.2, 50.0.0.3. Now class is same, 50.50.50, so this is called LAN 2. But 50 is different from 20. So if we connect this, it will not connect because network ID is different. So when we connect this switch with one router, and router is connected to this. Now router is a device which works on different network ID. For example, here router is using 20.0.0.10 IP. Here router is using 50.0.0.10 IP. So on the both port of router having different network ID, and router is going to connect with 20 to 50. So different network ID plus router concept becomes WAN. So this is the exact definition of WAN. Thank you so much. Hello friends, our today's topic is FLSM, because in our last lecture we have discussed about what is IP address, what is LAN and WAN, what is subnet mask. That IP address is my unique identity, subnet mask is used to divide LAN and WAN, network ID and host ID, and with the network ID and host ID concept you can make LAN and WAN. Now what is fixed length subnet mask? You need to know about this. The short form of fixed length subnet mask is FLSM. So in FLSM we need to verify like how many networks are in one IP address, how many hosts are in one IP address. So if we take A class very first, like the subnet mask is 255.0.0.0. So we know that network part is 8 and host part is 24. 24 means in this we are going to use 16 million approx IP addresses. So in FLSM what we need to find? We need to find from IP address. So this is subnet mask. I am taking any 1 to 126 IP address like 20.0.0.0. This is my network. So what we need to find in FLSM? So we need to find from IP address what is my network ID, what is the first valid IP address that I can use in my network, what is my last valid IP address that I can use, and what is broadcast ID. So in FLSM we need to know about this part. Okay, so I'm taking an example. 20.0.0.0/8. 8 means that 8 bit are on. So what is the network ID for this? So 20.0.0.0. The very first IP address is known as network ID. For example, I am writing here 120.20.0.0.100. So the network ID of this part should be 20.0.0.0. The first valid IP. Valid IP means that IP address I am going to assign to my computer. So we know that this is network ID, this is first IP, this is last IP, and this is broadcast ID. We know that with LAN and WAN, if 255 subnet mask 000 is there, then 20 should be same in this part. It should be same, and this part is variable. So first IP address is 001. And what is my broadcast ID? If my IP start from 000, then definitely it should end with 255, 255, 255. So if after network ID my first valid IP should be there, then before broadcast ID my last IP address should be there. It is the example of A class only. Understand? Like if we have to complete 16 million IP address, then first time it will go to 0 to 255, then 1 should be there. Again 0 to 255, then 2 should be there. Again 0 to 255, then 3. Then 256 times 256 should be there. Then this part will become 255. Then 1 should be there when again this process 0 to 255, 0 to 255. So 256 multiply 256 multiply 256 is equal to 16 million IP. Okay, let me take one example of B class first. For example, I have 160.0.1.1. This is IP address, and 16 is the on bits are there. So network ID, first IP, last IP, and broadcast ID. So we know that the subnet mask is 255.255.0.0 is there, this part. Understand? So 160.0 remains same in network ID, first IP, last IP, broadcast ID, this part. Okay, so network ID is represented with 0 and 0, as I told you in A class. Broadcast ID is represented with 255, 255. So it is starting IP address, it is last broadcast IP address. So first valid IP is 0.1, last valid IP is 255, 254. Easy. And in C class, for example, this is 1 or 10 or 100. No worry about it. Class will start with 0 only. 200, 1, 2, 3, 24. So the network ID, first IP, last IP, and broadcast ID. But first I have to write FLSM, fixed length subnet mask 0. So 3 times 255, it means 200, 1 and 2. It remains same. Okay. So starting from 0, first IP is 1, last IP is 254, and end IP is 255. So in FLSM we need to find what is my network ID, what is my broadcast ID, what is my first IP, and what is my last IP address. Thank you so much. Hello friends, our today's topic is about VLSM, variable length subnet mask, and the main concept name is subnetting, and it is the most important topic of your networking. Like in our last videos we have discussed about LAN and WAN, we have discussed about IPv4, subnet mask, and at last we have discussed about FLSM. In FLSM we know that we need to find our network ID, first and last IP, and after that broadcast ID. But in FLSM there is a problem. What is the problem? Like For example, if I need 300 IP address within one LAN network, then I'm not able to choose C class, because C class subnet mask is 255.0.0.0, sorry, 255.255.0. Okay, so in this, network ID is of 24-bit, but host ID is for 8-bit only, so 2 raised to power 8 means 256 IP address. So I need 300 IP address, so I have to move on into B class. So in B class, 16-bit host means 65536 IP. Now the concept is, like, if I'm taking 300 IP address from this range, 65536 IP address, then 65236 IP addresses are not able to use in any other network. Why? Because the WAN rule is this, that you can choose different network ID with the router. So I have to use all the IP address in one class, but I need only 300 IP address, so I have a big problem about it. To solve the wastage of IP address, that's why we use VLSM, variable length subnet mask. So the overall concept name is subnetting. So what is subnetting? Subnetting is the process of divide one large network. For example, this is large network. Divide one large network into small subnetworks. Small subnetworks. Like I have to divide this room into 2 parts. So 2 network will be there, 4 network will be there, 8 network will be there, 16 network will be there. Like I have to divide one exact space into 2 part, 4 part, 8 part, 16 part, 32 part. Okay, let me take an example. So I'm going to start with C class. So I'm taking an example of this 192.168.1.0/24. So this is, I know this is class full network, but I'm going to choose it as a classless network. Okay. So first of all, we need to follow some basic steps in subnetting. So first step is find VLSM. Okay, so 24 means 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And after that all zeros. Like all 0 means 8 zeros. So VLSM is 255, 255, 2550. And the value remains this. This is known your magic value. Like we don't need to follow fixed bit. The values remaining is known as magic value. And the third step is block size. The formula of block size is 2556 minus 0 magic value. So I have to minus magic value into 256. Fourth and fifth part is number of networks. Like if we are using this network, what are the number of networks? So I'm using a number of network is 2 raised to power n. N means on bit. So I don't have to choose from already fixed bit. Like in A class 8-bit are fixed, B class 16-bit are fixed, and C class 24-bit are fixed. So I don't have to choose from this. I have to choose from magic number. So how many bits are on? No one is on. So n value is 0, network is 1. Number of host 2 raised to power h. So h means off bit. So 2 raised to power, all bits are off, 256. So within one network I have 256 IP. Yesterday's video, last videos we have discussed that in one network 256 IP. So I have to find network ID, first IP, last IP and broadcast ID. So what is my network ID? 192.168.1.0. First IP is 192.168.1.1. Last IP is 192.168.1.2, and broadcast ID is 254. This is second IP, this is last IP, and this is broadcast ID. So this is the steps that we have to follow in subnetting. Okay, so this was the classful network. Let me take an example of /25. Okay, I will write the steps on notepad. Okay, wait. So my first step is find VLSM. So I will write it on this. After that, magic value. This one. Okay, so it will help you to make the video good. And after that magic value, we need to find block size. And after that, I have to find number of network. And at last, I have to find number of host. And after that, we need to find one more thing: valid network, valid host. So this is after this. Okay, so I am taking an example of one number. Okay, so let me take 200.0.0.0/ I'm using 25 here, like 1 bit is on in this. Okay, so 1 bit is on this one. Okay, so what is the VLSM here? I'm taking one space here for understanding you. What is VLSM here? 25 means 255, 255, 255. These are the 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. Now 25 means one more bit is on. 25, 26, 27, 28, 29, 30, 31, 32. Okay, so when we do binary to decimal, then this value should be 128. So now this is my subnet mask. This is variable length subnet mask. So now magic value is 128. Block size is 256 minus 128 is equal to 128. Number of network 2 raised to power n, 1 bit is on. So number of network 2. Number of host are 2 raised to power h, 7 zeros are there. So this is the exact value. Like within 2 network, 128 IPs. So what I have to find? Network ID, first IP, last IP, and broadcast ID. So I have 2 networks. Okay, the network is 200.0.0.0 and the block size is 128. So 200.0.0.128 is my next network. So in this, first IP should be 200.0.0.1, last IP 126, and broadcast ID is 127. So this is 129 is my first IP, last IP is 254, and broadcast IP is 255. Okay, if we need to find now what is valid network and what is host. So you have seen that first network ID and last broadcast ID is not used in host. Okay, so the valid host are 2 raised to power h minus 2. Like if 128 are the host, then valid host are 126. And valid network is same as 2 raised to power n minus 2. Like if 2 raised to power n 1. So here we have only 2 networks. So in this, valid networks are 2. So network I have to find like this. Sorry, valid host I have to find like 128 minus 2. Okay, so if I have 256 IP in one network, then 254 is the valid IP. If 128 IPs are valid, then 126. Like we have to do with minus 2. Okay, let me take an example, another example. Okay, so 25, 26, 27, for example, I am doing for 29. Okay, so what I have to do for 29, like 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 24, 25, 26, 27, 28, 29. This one. So VLSM is 255, 255, 255, 248. Because binary to decimal, 2 raised to power 7, 6, this one. 248 is the magic value. Block size formula remains same. Number of network 2 raised to power 5. Number of hosts 2 raised to power 3. Now, how I am easily understanding the concept, because I am using these values. 5 ones means 5n. 3 zeros means h is equal to 3. 32 network and 8 host. But exactly I am using 30 network here because 0 network I am not going to use. Okay? And after that 200 last network 200 00 248 I am also not going to use. But here I have to work on valid host. So valid hosts are like 6. How? Now 1, 2, 3, 4, 5 up to 32 network I have. First network is 200 000. Block size is 8. 200 008, 16, 24, 32 like this. And after that 1 to 6 is the valid IP, first and last. 7 is your broadcast. 9 to 14 and 15 is your broadcast. 17 to 22, 23. 25 to 30, 31. Like you have to follow the same rule that I have used. Okay, so I will write, like if I am going to use all the network, then I am showing you the value, exact value of slash. So when I am using slash 24, okay, then I know that this is class full. 25 class slash 26, 27, 28, 29, 30. So I am going to provide a cheat sheet. Okay, here is cheat sheet for you. 255 means easy. 255, 255, 0. Now 25 means 1 bit is on 128. 2 bit is on 128 plus 64 192. Here 128 plus 64 plus 32 224. So you have to solve these R values, because in video I can solve only limited values. Okay, so just solve this. 255, 255, 255, 248. This one I have solved just right now, and 252. So exact what you have to see. Okay, in this I have 256 IPs, but when I solve this 128 IP, 64 IP, 32 IP, 16, 8 and 4. These are the total hosts that we are using. So if anybody asks from you like what are the valid hosts, so just do one thing, minus 2, minus 2, minus 2, minus 2, minus 2. So the valid IPs in slash 30 is 2. So I am writing with this. So valid IP in this 254, 126, 62, 30, 14, 6 and 2. So with the help of this we can do subnetting. Thank you so much. Hello friends. Our today's topic is about IP addressing configuration. This is the totally practical topic. So today I'm going to let you know about like how to configure router and how to provide IP address with subnetting on our design. Okay, so let me start with the design. So I'm going to use this router 1, 2, 3 router, and I'm going to use 3 switch 2960 is there, These router and switch we have already discussed in our last lecture, like what is router, what is switch. So in end device we can get 1 2 1 2 1 2. Okay, you can choose one more IP if you need, like it's about you that you are going to choose how many PC in your network. Okay, so I told you about in last Cisco packet tracer video, like that if you are going to connect PC with switch, then you are going to use where straight cable, fast Ethernet, fast Ethernet, fast Ethernet. So I'm going to use this command. Sorry, this is cable connectivity. After that I have to put command here. So from switch you can choose any fast Ethernet interface, it's up to you. So our LAN network, 3 LAN networks are completed now. Router to switch I am going to choose again fast Ethernet. Okay, but I told you that if you are going to connect with router to router, then you can choose cross cable. Okay, but for example you are not going to choose fast Ethernet cable here, then you can choose off the router. You can choose here HWIC2T port here and on the router. Okay, so with this, what you can do, you can add an WAN interface card in your router. After this you are able to connect your router with serial cable. Here is serial cable. So connect serial 000 000 001 000. Okay, so no worry about like 001 is going to connect with 001 only. You can connect it with 000 only. Okay, so now here I need to provide IP address. Okay, first I want to explain. For example, this is my first network. Okay, second network and third network. So in these network we have 1, 2, 3 and 4. Total 4 IP I need. Here I also need only 4 IP address. Okay. So in last subnetting video, in that video we have discussed about like if we need 2 valid IP, then I'm going to choose /30, 6 valid IP /29, 14 valid IP /28. So here I need only 4 IP, so I am able to choose /29 here. Okay, 4 IP. I'm erasing this and I'm writing here /29, because with the help of subnetting we have to configure this. And here we have a network where we need only 2 IP address, so I can choose /30 here, /30, because we need only 2 IP address. And now in FLSM we have to use about like A class IP, B class IP, C class IP. But with the help of VLSM you can choose any IP address here. Okay, for example here you want to use another network, here another or another. For example, here you want to choose, like I'm just taking an example, here you want to use A class, then you can choose this. Here you want to use B class, then you can choose /29. Here you can choose C class. Okay, so within WAN link you can choose any IP address, like here 20.0.0.0/30 and 30.0.0.0/30. So the meaning of these IP addresses, like here I can put IP address 1, 2, 3 and F0/0 is 10.0.0.4. Here I can give 172.16.0.4. Here I can give 192.168.1.4, and the IP address assigned to fast Ethernet port is known as the default gateway for LAN. So let me start with practical right now. Okay, so I hope that you understand the concept. So first of all, I am going to configure my, okay, let me erase this. 10.0.0.1 255 255 255 248 because /29 I am using and gateway is 10.0.0.4. So I am just copy the gateway because I have to choose in another network also. 10.0.0.2 and subnet mask I have to change manually. 10.0.0.3 255 255 255 248 and 10.0.0.4 is the gateway. Okay, so I can write in sticky notes also 10.0.0.4. Here I want to use 172.16.0.4. Here I am using 192.168.1.4. The IP address here is 20.0.0.1 but /30, 20.0.0.2, 30.0.0.1 and 30.0.0.2. Okay, so in this also I have to choose 20.0.0.1, 255, 255, 255, 248, 20.0.0.4. So I am going to copy this subnet mask because I have to type again and again. 20.0.0.2. So paste the subnet mask 20.0.0.4. This is easy. 20.0.0.3. Okay. 20.0.0.4. So here, oh sorry, my mistake. Here I have to choose 172.16.0.1 because I am choosing WAN for 20 IP address. So not an issue. We can change just within 1 minute. Here I am using 2 and 4. Three and 4. Okay, so here I have to choose IP address with 192. To 48 and 192.168.1.4. So if you are going to start with first time, then sometime you will face some problems, but it is very easy coding. You don't have to worry about it. Okay, so the last IP address is done. So my PC's IP addresses are configured. Now I have to configure router, the important part. Okay, so in our last video we have discussed about CLI command. We know that we have to put no here. First command is enable, and after that I am going to choose config terminal command. So now how to provide IP address to router. So we have two ports of router, fast Ethernet and serial. So I am going to give interface fast Ethernet 0x0 IP address 10.0.0.4. So this is the gateway for LAN 1 and the subnet mask should be 248. Okay, actually I have put tab, so that's why you are seeing 3 commands. So by default the link of router is down, so you have to use command here no shutdown. When you will use command no shutdown, the link will be up if it is connected to switch. If it is connected to router, again router, then you have to no shut command, put no shut command on another router also. So exit interface serial 0.0/0/0 IP address 20.0.0.1 and here I have to use 252 because /30 I am using. No shutdown, exit. Okay, so I told you about one thing, that if you want to see running configuration, then you have to use that command in enable mode. Show run, that you can easily see this IP address is configured with this is configured with this. Okay, I will going to configure second and third router but before that I'm going to introduce one more command. For example, you are checking show run command in config mode. Okay, show run, then it will provide you error invalid. So the concept is, if you are going to use enable mode command in config mode, then you can put do keyword before that. Like if you are using show run in enable mode, it is right, but if you are going to use show run in configuration mode, then you have to put do keyword before command. This one, like do show history, do show IP interface brief. So this is the basic command. Now move on to router 2. So on router 2 I have 3 interface. Okay, I am using short forms, enable and config. Okay, so I have 3 interface, fast Ethernet, serial and serial 001. So it's up to you that you are going to configure at very first which interface. 172.16.0.4, 255, 255, 255, 248, and then no shutdown. Easy. And after that, exit this interface, go for interface serial 000, IP address. Now this port IP is 20001, so definitely this should be 20002. 255, 255, 255, 252. No shutdown. So this link should be up. That's it. Okay, you want to see the history in between configuration, then you can put command do show history. Like if you want to see this, but our one more interface is left. Interface serial 0/0/1, IP address. This one 30001, no shut. So this one. Okay, if you want to save the configuration, then I told you that you can use command write, but if you are going to use in this configuration mode, then you can put do write. Building configuration, okay. In first router I'm going to change do write. Now this configuration is saved. Okay, now move on to third router. Third router is also same as enable configure terminal interface fast Ethernet 0/0, IP address 192.168, sorry 195, I wrote 195 instead of 192, 1.4, 255, 255, 255, 248. So again no shutdown, the link is up, and after that interface serial 0/0/0, IP address 30002, and no shutdown. So if you want to save this, do right. Okay, so this is done with my IP addressing with subnetting. Okay, now you want to check basic command here, like okay, sometime one more thing, sometime this error will be there translating domain server, then you have to choose Control-Shift-6. Okay, you have to choose Control-Shift-6 in this, and after using this, name lookup will be aborted. So show IP interface brief. It will show you which interface is assigned with which IP address. Okay, show IP route. So show IP route will provide you the routing information, like 10 and 20 are the direct network of this router. Okay, so this was the configuration of IP addressing. Thank you. Hello friends, our today's topic is about IPv4 private IP addressing. Okay, in last video we have discussed about the practical, like how IPv4 addressing will be configured. Okay, but today's video we have to discuss about like why we need private IP address. Okay, first of all, we need to know about the private IP address. As we know that we have classes. So if we have classes like A class 1 to 126, B class 128 to 191, and C class 192 to 223. Okay, so in that the range of IPv4 addresses are same, but these all are known as public IP address, like those are the routable IP address over the internet. So the private address range is from A class is 10.0.0.0 to 10.255 to 55 to 55, and 172.16.0.0 to 172.31 to 55 to 55, and from C class 192.168.0.0.0 to 192.168 to 55 to 55. These are the reserved private IPv4 addresses, and these IP addresses are not routable over the internet. Like it turns out that private IPs also came in handy as a means to save valuable public IP addresses, like public IPv4 space. Okay, in other words, I want to explain that without these private addressing, we would not have any more public IPv4 address to hand out today's to a new device. Yes, we have subnetting options, we have a NAT options also, but in any cases, private IPv4 addresses go a long way because they can be used by many. And many different peoples, many businesses, many devices are used with this. So you do have to turn them into some sort of public address if you want to use. Okay, so private IP addresses are not able to use, but in many companies, everyone is going to use with private IP address. These are not public, these are private IP addresses, and these IP addresses are not routable. So with the help of private IP address, we are easily have to use and save public IP addresses. Thank you so much. Hello friends, our today's topic is about one of the most trending topic of our networking, which name is IPv6. Okay, in our last video we have discussed about IPv4 address. Okay, and we have configured our IPv4 address on Cisco Packet Tracer, and we have discussed about how to do subnetting and how to do configuration on routers and PCs. So our today's topic is IPv6 Internet Protocol version 6. Internet Protocol version 6. Okay, first of all, why we need IPv6? Actually, in our IPv4 addresses, if we talk about IPv4, then in IPv4 address we have a 32-bit address and 4.3 billion IPv4 addresses are there. And we know that all over the world population is going to be 8 billion. Okay, within just years or 2 years, it will become 8 billion. And we are using private IP address, we are using subnetting. But at one time IPv4 address are going to not in the use in the market because it is already used. So that's why we need one new IP address. That name is IPv6. So what is the difference between IPv4 and IPv6? In IPv4 it was 32-bit address, it was the decimal address, it was represented by dot. Okay, it was represented with 4 octet. It has classes, and we have done with classes subnet mask. And in IPv4 address is what we have learned about classes is done dot 4.3 billion IPv4 address approximate. So in IPv6 it is 128-bit address. It is in the hexadecimal format. Okay, it is represented by colon. It is represented like this: 16 colon 16 16. This. So it is a huge and large IP address. It has no concept of classes. Okay. Instead of subnet mask, IPv6 is using CIDR value, like we call it prefix length. Like in IPv4 we were using like this: 10.00/8 172.16.00/16 192.168.1.0/24. Okay, and after that we will convert this value into subnet mask like 255.0.0.0, 255.255.0.0 and 3 times 255.0. But in this IPv6 we can only choose prefix length. Okay, so how to write IPv6 address? Okay, so first of all, for example, this is my IPv6 address. I'm using IPv6 address 0000.0001 and 1 2 3 4 5 6 7 8. Okay, so 8 hexas are there. So in this I can choose like 0db8 010001. Like instead of 40 I can put single 0. Okay, so if you want to shorten the expression of IPv6 address, you can also use like this: 2001 0db8 01:1. Like group of 0 can be represented with double colon. But for example, sometime we got 2001 001 0.001 2 3 4 5 6 7 1. So now we have two group of zeros. Okay, so you can write this IPv6 address like this, or you can write this double colon 1, but you are not allowed to use two double colons like 2001 double colons 1 double colon 1. This is wrong, because then router will confuse like which part has 20, which part has 3 zeros. So this is the expressions for shorting the router. Now for example, I was writing IPv4 addresses like this. Sorry, IPv4 like 10.0.0.1/8. So 8 part will be the network ID and this part will be the host ID. 172.16.1.1.16. This part should be the network ID and this part will be the host ID. So in IPv6, for example, you are writing 2001. I'm using 2001 because it belongs to private IP address. 10. I'm just writing like this. 0. For example, I am writing here 16. So it means 16-bit is network, rest all part will be used as a host IP address. So that's why that's why I just want to let you know that /64 up to /64 we are not able to use, because this is global prefix that I will explain you in another next videos about it. Okay, so in IPv4 we were using like 8, 16, 24 and 32, but in IPv6 we have to use 16, 32 like this and 128. 16, 32, 48, 64, 80, 96, 112 and 128. So this is the basic description. When you are going to work on practical, then you will easily understand. For example, instead of 16, I am using here 96. So means 16, 32, 48, 64, 80, 96. So this part is your network part and this part will be your host part. So when you will configure this IPv6 address, then you will easily understand about the concept of IPv6. Thank you so much. Hello guys. Today we are going to configure IPv6 addressing on Cisco Packet Tracer. So in our last video we have configured IPv4 address, and we have taken 5 to 6 network, and we have configured PCs, after that routers. So same as IPv4, we have to work on IPv6. In our theory part we have discussed about IPv6 address is 128-bit and it is represented by column. Okay, so here we have 5 networks. First network, second network, third network, fourth and fifth network. Okay, so I need to take IPv6 address. So here I can choose 2001 colon 10:/96. I'm just taking an example. So I'm taking 2001. So 96 represents networks and 32 bits are the host. So here our second network is 20:96. 2001 30:96. 2001 40:96, and at last this one. So I have 5 networks. So how I will configure it? I will provide it 10:1 IP, 10:2 IP, 20:1 2, 30:1 2, and the gateway should be any. F0/0 should be configured with 2001 10:3, 20:3 and 30:3. And after that the upper network WAN links 40:1, 40:2, 50:1 and 50:2. So I will configure it like this. Okay, so I will move to my PC configuration part. Okay, so on the PC first I will erase this. On PC in IPv6 configuration I can give IP address 2001 10:1 and /96. This is known as link local address. So gateway should be 10.0.0.3. So double colon represents all zeros, group of zeros. So here I am going to represent 10:2/96 and 10:3. The second network same as 10, but here I will choose network 20:1 96 3. 20:2. So 2001 I have taken just for private IP address. 296 3, and in last $30:1/96 and 2001 30:3. Okay, so now it's time to configure router. So if you want to write, then you can use sticky notes here like these. This is your 10:3. Okay, I will put my keyboard here, that's why it is easy for me. And after that this is 20:3. This is 30:3. So upper network 2001 40:1 I have to configure. First I will write it that you will easily understand in my video. 50:1 50:2. So I'm click on this router CLI. Okay, in real router you have to use console cable and PC, but on Cisco packet tracer you can directly click in CLI. Okay, so when you are going to configure IPv6 addressing, okay, so one thing you have to be clear in your mind that IPv6 unicast routing should be there. The command IPv6 unicast routing, you have to put this command, because if you don't use this command, then you are able to give IP address to router, but you are not able to give for routing. So interface FA0 by 0 IPv6 address 2001 10:3/96. No shutdown. Exit. Interface serial 0/0. It is same as we have configured IPv4 address, but the address is changed. 40:1/96. No shutdown. So if you want to save all the configuration, just put do right here, and do show history you can use to see the command that you have used on this. Okay, so next on route 2, here no, enable config, same as IPv6 unicast routing FA0 by 0 IPv6 address 2001 20:3/96, which is the gateway for your LAN, and serial 00 IPv6 address 40:2. This link is connected to router 1, the first one. Okay, and serial 001 is for 50, where it is, sorry, 50:001, and no shut, do right. So our second router is also configured. Now move on to third router. No enable config, like these basic commands, enable configuration you have to use every time. IPv6 unicast routing, interface fast Ethernet 0 by 0. The gateway of this network is 30:3/96. No shutdown. And exit interface serial 0/0/0 IPv6 address, and 2001 50:2/96. No shutdown and do right. Okay, so every router is configured, and after that you can check the basic commands. Show IPv6 interface brief, and in that you can see fast Ethernet is up, and IP address is 2001 10:3, and serial interface IP is 2001 40:1. Okay, same as show IPv6 root. In show IPv6 root, C stands for direct network. So 10 and 40 are your direct network, and L stands for local. Like it will represent your own IP address but with /128. Okay, so this was the configuration of IPv6 addressing. Thank you. Hello guys. After the configuration of IPv6 address on Cisco Packet Tracer, we have to compare some IPv6 address types here. So today we are going to discuss about IPv6 address types. In address types, we have so many things in this. Like IPv6 has so many address, like it has unicast, link local, unique local, and so many addresses are there. So we have to discuss it one by one, because IPv4 consists unicast, multicast, anycast address. In this, an interface is expected to have multiple addresses. Okay, so it also listen to various multicast address, sometime unicast, sometime multicast, sometime broadcast. So in IPv6, yes, broadcast address no longer exists, sorry, but rather another addresses are already exist. So first of all, we have one address named unicast. Here you can see unicast is there. So unicast is one-to-one communication. We know that one-to-one communication. In this unicast address, it uniquely identify an interface and transmission to a single SIP. Okay. In unicast, after unicast, we have link local address. In link local address, scope is limited to directly attached network. The link local address is represented with FE80:/10. It is link local address. And after link local, we have unique local address. Technically, the scope is global. Unique local address, technically its scope is global, but it is really limited to your network. We can say it is similar to private IPv4 addresses. IPv4 private IP address is similar to this, but unique local address, the type of unique local is FC00:7. And after this, we have global unicast. Its scope is global. It is similar to IPv4's public IP address, but in IPv6 it is of like this. Okay, after that, after unicast, link local and multicast, we have address a global unicast multicast. Multicast, you know that transmission to several receipts, one-to-many transmission. In this we have two types also. The two types are, one are assigned. First of all, I have to remove this. Multicasts are divided into assigned, and also multicasts are divided into solicited node. Okay, so assigned address are FF0S:8, and these address FF02:1, FF00:000, but it is not used as a practical, so it is just address of multicast. So the important thing after the multicast is anycast address. Anycast is a collection of devices share the same IPv6 address. Transmission is to the closest address, like topographically, and it is identical to unicast, so only difference is administrative. Okay, so anycast address is a collection of devices which use same IPv6 addresses. And after that we have modified EUI. First of all, we need to understand what is EUI. So this is the theory topic. EUI is extended unique identifier. Now what is this actually? So EUI64 is, for example, a host can automatically assign itself a unique 64-bit IPv6 interface identifier. Okay, we don't need manual configuration or DHCP. In EUI, it will automatically assign. So EUI64 is also like modified also. There is a type is modified also. In this, the 7th bit is the universal bit. So yeah, 1 for universal, and 0 is for local. And at last we have one more type, and the type name is, okay, so I will write it only. It is auto configuration. Auto configuration is similar to DHCP in IPv4. Okay, so router running in IPv6 can give the network prefix and gateway address to client looking for an IPv6 address. Okay, so these are the IPv6 address types. Thank you so much. Hello friends. So in today's video we will discuss about IP parameters. So I need to verify the IP parameters in different client operating systems. Okay, so current this time I'm using my Windows 10 here. Okay, so this is the screenshot that I have taken from my window 10. So within IPv4 we can give IP address, subnet mask, default gateway, also DNS server. So if you want to see the practical, then I will show you. Then in control panel we have to click in control panel, network and internet. After that, after network and internet, network and sharing center, change adapter setting, and here you can give IP address, IPv4. So here we have different things like obtain IP address automatically and use the following IP address. So here you can give IP address, subnet mask, default gateway and DNS server. Okay, in advance, if you want to give multiple IP address to your operating system, then you can add here TCP IP address, DNS address and your WINS address here. Okay, so I'm not going to give address this time because my system is connected to internet, because IP is based on internet. So if I will change the IP address, then definitely my internet goes shut down. So that's why I have taken screenshot. Sorry. So this is the screenshot taken from window 10. In this you can see IP address, subnet mask, gateway like 192.168.1.25, gateway is 1.1 and subnet mask is 255.0.255.255.255.0. So that it is window 10 operating system. So there is no difference of IP addressing in Mac operating system, but the difference is virtually like Mac operating system is different, but in Mac operating system you can give Ethernet IP address, and here you can see the status, cable is unplugged. After that you have to give it manually IP address, subnet mask, and router keyword knows same as default gateway. Like in Windows operating system we know it as default gateway and in IP Mac configuration it is known as router. So here we have DNS server. So besides this, I have taken screenshot for Linux operating system also. Here same we can use IP address, broadcast address, subnet mask, default root and primary DNS. So the IP configuration is easy on each and every operating system. Thank you so much. Hello friends, our today's topic is about wireless principles. As we know that Wi-Fi device or Wi-Fi router is used to connect with the radio frequency or the radiations with our laptops. So if we are not able to connect our device with switch or router, then we can directly connect with wireless. Okay, like my mobile is not able to connect with switch. Okay, my tab is not able to connect with switch or router, so I can connect it with wireless router. So today we have to discuss about wireless principles, like within wireless what are the things used and how Wi-Fi router is work. Okay, so first of all I have a point, non-overlapping Wi-Fi channel. Okay, so in non-overlapping Wi-Fi channel, what is this? Okay, first of all we need to know about that. It might be obvious that the wireless device, okay, for example this is wireless device or any access point which has antennas, all the wireless device and access point should all be capable of operating on the same band. Okay, let me explain you in different manner. For example, a 5 gigahertz wireless phone can communicate only with the access point that offer Wi-Fi service on 5 gigahertz channel. Okay, so this is my mobile phone. It has a 5 gigahertz frequency. So it is communicate with the Wi-Fi service if this access point provides the 5 gigahertz channel. Okay, in addition the device and access point must also share a compatibility with the part of 802.11. This is the standard by IEEE 802.1 standard, this port. Okay, as we know that IEEE 802.11 Wi-Fi standards evolves and develops new amendments in the functionality of the get purposed. So we have to think about these things, and it is common to see the amendments which still used to distinguish specific functions. So non-overlapping Wi-Fi channel is example of this. After that we have SSID. What is SSID? SSID is Service Set Identifier. Okay, so it is known as your broadcast ID actually. Okay, when for example you are going to connect your laptop with your Wi-Fi router, then you can check. There are so many wireless names are there. Okay, so SSID is your Service Set Identifier. Service Set Identifier. Okay, it is also under the 802.11 wireless networking standard. It is known as service set. It is your broadcast ID of your Wi-Fi name. Okay, for example, I have XYZ private limited company. Okay, so I want to connect with my Wi-Fi network. So the name of the company should be XYZ private limited, and easily we can connect with the help of service set identifier. And when it is connected with the service set identifier after giving its wireless password, then automatically my PC's MAC address is assigned with my Wi-Fi router. Within we have so many modes, we have so many frequencies are there. Okay, so MAC address is assigned with my Wi-Fi channels. Okay, the third part is my radio frequency RF. Okay, now in wired link the electrical signal is used. For example, if you are working with switch or router, what is known as RF? RF is your radio frequency. Radio frequency is used in wireless, because if you want to send data with one system to another system with wire, then you know that we have electrical signal is used. Electrical signal is used at one end and at another end. So wire itself is a continuous and conductive, so that signal can propagate rather easily. But in wireless we don't have any physical standards, so we have to carry our signal with some radiations. So that signals that carry our electrical signals over air or free space, okay, the radiations, this is done with radio frequency. So radio frequency is used to connect our wireless devices with each other, like sender and receiver easily can get the information and send the data from one interface to another interface. Okay, so the last point in wireless is encryption, because wireless networks are complex. Okay, so encryption is important in this time, because if we don't have any wireless network security, so anybody can access our data easily within our given range. Okay, so why we need encryption in this? So first of all I will remove this. Okay, so encryption is used for like identify the endpoints of wireless connection. Okay, you want to verify the end users, you have to protect with eavesdropping. Okay, you want to prevent your eavesdrop, and after that you want to protect from data tampering. You also need encryption technique. So in encryption you can use authentication. Okay, so we have authentication also, WEP privacy as well as WPA privacy this time. Open authentication is like your Wi-Fi router with free Wi-Fi. They have no Wi-Fi password, so you can connect easily. WEP is wired equivalent privacy. This one is in encryption. WEP is wired equivalent privacy, but it is a non-secure nowadays. So nowadays we are using WPA, wireless protected access. It is secure because in this encryption part is more, we can use our special case sensitive words like @ hash and the percentage sign in this. So these were the wireless principles. Thank you. Hello guys. In this video we are going to discuss about virtualization fundamentals, like what are virtual machines. Okay, So virtualization is the process in which we can use multiple operating systems at one time, and the virtual machine is same as like a software in which you can run multiple operating system at one time. So for virtual machine installation you can use so many software. We have so many software that are used nowadays. So we have VMware in which we can install multiple operating system. We can use VirtualBox. Some virtual boxes are from Open and some belongs to Oracle VirtualBox. So we have so many virtual machines are there. So in this video I am going to configure one virtual machine, and first of all I need to install VirtualBox or VMware. So I already have set up. In this setup I'm going to click on VMware workstation. This is my old version, like it is already cracked. So I have to click on this. This is VM workstations 8. So it is going to install. Like first of all you need to go for next, and like you want to use typical or custom here. Like typical program feature will be installed, so I am clicking on typical. So if you want to check the update, then you can click on this, otherwise you can untick this. And after that, if you want to improve your workstations, then you can click on this. So next, if you want to create shortcuts on desktop and start menu, then you can use this. Okay, let's continue this. Okay. So now it is going to install. In this VMware, we can install multiple operating system as I have told you before, and we can install Windows 7, Windows 10, Linux, Kali Linux, any operating system that you need, you can install in this VMware VirtualBox or VMware stations. Okay, so the package is installing because it is used for some requested operations. Okay. So it is installing. So it is taking some time because we have so many backend files. So this may take several minutes to install. It will install some tools. It will install some data backups. There are so many packages, like they have to set up for Windows operating system, Linux operating system, Mac operating system also. So that's why it is taking some time. So we have to wait for some time, and after installing and configuring all the things in VMware, we can install any operating system in this. Okay, so setup wizard is complete. It is finished. Now I have to check. There we have one key. If you have cracked version like paid version, you can click on this. And now you have to check that your VMware is installed or not. So it is installed. So now it is going to open. Yes, already I have installed Windows 7 machine in this. Okay, so if you want to install a new virtual machine, then we have to start from scratch. Click on create a new virtual machine, typical. Now if you want to install Windows 7 64-bit, then you have to click on 64, otherwise you can click on 32. If you have another operating system, then you can also install this. So I'm just taking an example of Windows 7 Ultimate 32-bit. Next, okay, so in this portion you have to give the product key. If you don't have product key, don't worry, after that you can update it. So full name you have to give XYZ, anything you want to give. If you want to give the password, then you can give password there. Next, click on this. Now it will take some time. It will make the directory. You can change the preference also. You can change the bits also. If you want to customize hardware, then in this memory, processors, network adapter, USB controller, then you can add or remove the functions. Like for example, you want to run the internet on this, so by default it is clicked on NAT, used to share the host IP address. But if you click on bridge, then you can use the internet direct from your main PC. Okay, so for this time I'm remaining it same. Finish. So my VMware is installed, and now my operating system is also going to install. So after installing this operating system, your Windows 7 will be there. So it will take some time. So that's why I already have installed the window. Okay, so you have to click on File, Open, and where your VMware is installed, virtual machine. So you can click on this and click on this. So you can open this and you can click on this, you can resume this, you can set the meeting settings or anything else. So this is all about the Windows 7. So already my setup is starting because it will take at least 20 to 30 minutes to complete. So after completing this, it will be installed like my original Windows 10, Windows 7 is using. So this is the part of virtual machine. Okay, so I already have installed. So this is all about virtual machine. Instead of VMware, you can also use VirtualBox or any other softwares. Thank you so much. Hello guys, again I'm in front of you. Today we are going to discuss about our next module, which is known as switching. So it is my 1.13 module, in which I have to discuss about various switching things. Okay, like we have a switch. So we need to discuss about how switch works and how it transfer frames from one interface to another frame. Okay, so in this switching concepts, we have to discuss about what is MAC address and how MAC address and its aging. Okay, and after that we have to discuss about what is a frame switch, like how to flood the data, what is broadcast access. So many things are there. So first of all, we need to know about the basic concept of what is switch. So switch is a layer 2 device. Layer 2 device means it is a device which is used to connect with PCs with each other. Okay, so this PC wants to send data to this, and it can easily send data transfer with the help of IP address. Okay, so we know that in our last video we have discussed about IPv4. In IPv4 we have seen that PCs are configured with IP address, but switch is not able to learn IP address here. Okay, so switch makes one table which name as MAC address table. Okay, now how one PC transfer data to another PC? So when one PC, for example 10.0.0.1 wants to ping with 10.0.0.2, so first time switch will broadcast. So in which switch will broadcast? So data transferred to everywhere. So it means this is known as like frame flooding. So it sends their frames to everyone, but frame is received by only 10.0.0.2. So after broadcast, it will go for unicast process. Okay, when every PC pings with like 3, 4, 5 ping with each other, then there is one table is made which known as MAC table. Here is port number 1 by 0 by 1, 0 by 2, 0 by 3. Then for example MAC address of first PC is A, second PC is B, third PC is C. So this is the process of MAC address. Now what is MAC address? MAC address is 48-bit hexadecimal address, which is known as your physical permanent address. So in switch, it learns the MAC address of every device and put that MAC address into the MAC table. So first time it will go with broadcast, but when first time broadcast is done, then in MAC table we got the entry, as I know that 3 entries are here, A, B and C, and obviously 1, 2, 3 systems are connected with switch. So if switch know the MAC address, then after that it will not go with broadcast technique, it will go with the unicast technique. So this is the process of actual switch from backend. Okay, So now I'm going to let you know about the practical of this. Okay, so I'm going to open my Cisco packet tracer. So I just want to show you about like how it will work. Wait. Okay, so Cisco packet tracer is open. So in Cisco packet tracer, I'm taking one switch here and I'm taking PCs from here, 1 2 3. Okay, so the PCs are connected with switch. For example, I have given 10.0.0.1 to first device, 10.0.0.2 to second device, 10.0.0.3 to third device. Okay, so first time, well, when it is transferring the data, you can check here. So I'm using, like, first time it sent the data from one to another, it will broadcast. It is sent by only this PC. So when again it wants to forward the packet from one interface to another, then it will not go with broadcast. But if PC sends data to another PC, for example, this one, this sent to this, successful. Now actually I have done pinging with this, so that it will not go for the broadcast, so it has given unicast. Why it is going with broadcast to multicast? So I have to check the things. So in this, first of all, I will up the fonts. Font size are again less. So an option, preference, font. I will use this. Okay, no issues. So you can check from here. This is go for show MAC address table. Show hyphen MAC address table. You can check MAC address is already assigned with this. So if MAC addresses are there, then switches go for one-to-one process. If MAC addresses are not there here, for example, MAC addresses are clear. For example, I will clear the MAC address manually, so it will again do broadcast. So this is the concept of switching technique. Thank you so much. Hello everyone. Our today's topic is about switching. So in our last video, we have learned about switching concept, what is MAC address, what is frame switching, how to connect with one switch with another switch. So today we have to do practical topic, which name is VLAN. First we will do the theory of VLAN, and in our next video we will do the practical. Okay, so the topic, as the name suggests, VLAN known as virtual LAN. Okay, so what is virtual LAN? So virtual LAN is used to break the broadcast domain of a switch. Broadcast domain on a switch. So in our theoretical part of switch, we know that the switch has one broadcast domain and many collision domain. Okay, so VLAN is virtual LAN which is used to break the broadcast domain. For an example, I will show you with an example. For example, you have connected 4 PC with your switch. Okay, so we know that by default every port is doing broadcasting. Why it will do broadcast? Because all the ports of switch like F0 by 1, 0 by 2, 0 by 3, these all port of switch by default the member of VLAN number 1. It is known as default VLAN. So VLAN 1 is known as default VLAN, and by default all the ports of switch are the member of this. So if our IP address is like 192.168.1.1, 1.2, 1.3 and 1.4. So if I will ping to my broadcast ID 255, I am using /24. So if I ping from this PC to broadcast, then 2, 3, 4 means every PC will reply to my first PC. Okay, but in VLAN what we can do, for example, if you want to divide these two PC in one domain and these two PC in one domain, so what we can do, we can make VLAN number 2 or VLAN number 3 here, and after that I will assign the specific port to specific VLAN. So it is used to break the broadcast domain. So in VLAN, what we need to learn about it? So first of all, VLAN is a numbered range. So by default, I told you that VLAN 1 is default VLAN. Okay. So 1 to 1005, it is a range of numbers in which 1, 1002, 1003, 1004 and 1005. These are already made VLAN on every switch. Okay, I will check on Cisco Packet Tracer and let you know about it in our next video. So by default, all the ports are in VLAN 1 by default. Okay, so these are the already made VLAN. So if we want to make VLAN, so we can use this number range. Like we can make VLAN number 2, VLAN number 3, VLAN number 400, VLAN number 1000. So we can choose any number which I need. Okay, so maximum VLANs ported locally is 255. Okay, but we can extend the range. And after that, what we need to learn, if our switch is connected with our PC, then that port is named as access port. Okay, access port. So if switch is connected to switch or switch is connected to router, for example, then that port is not renamed as access port, it is the trunk port. Trunk. So why we use trunk? Trunk is used to transfer VLAN database from one interface to another interface. So this is all about the theoretical of VLAN, like VLAN number range, access port and trunk port. In our next video, we will discuss about how to configure VLAN on switch. Yes, one more thing I just want to discuss here. VLAN is divided into two parts, like we can transfer data as well as we can transfer voice. It's up to you that with the help of VLAN you are making data VLAN or you are making voice VLAN. So in our next video we will talk about the practical of VLAN. Thank you so much. Hello everyone. Our today's topic is practical of virtual LAN. So in our last video we have discussed about access port, trunk port, VLAN range. So in this video we will practically implement how to create the VLAN. So first of all, I need to have one switch. Okay, and I need to take PCs here. For example, 4 PCs are there. Okay, I will take one more switch here, because we have to implement VLANs on multiple switches. So I will use 2 ports here. Okay, so I'm going to connect PCs with switch. Okay, and switch to switch is connected with cross cable because these are known as same devices. So okay, so this is a LAN. So LAN means devices are connected with same network ID. So I'm just taking 192.168.1.1, 192.168.1.2. I will copy this so that it is easy to implement the configuration. 3, 4, 5. Because first we need to check the broadcast domain, so I will ping to broadcast ID. So if everyone will be pinged, first of all you can check with this part also. Okay, you will check here successful. Okay, so I am going to ping the broadcast ID first, like ping 192.168.1.1. 1.192.168.1.255. So you can check 2, 5, 6, 3, 4. Everybody is replying to my PC 1.1. It means if I am sending hello in one classroom, then every student will reply to me. This is called broadcast process. Okay, so what we can do with the help of VLAN? So first of all, on our first switch, I will put the command show VLAN, option, preference, font. So I will change the font number according to my switch, but it is not going to change. It's okay. It is visible. Show VLAN. Okay. So in show VLAN, what you can see by default here is VLAN 1, 1002, 1003, 1004, and 1005. And by default, all the ports of switch F0 by 1, F0 by 2, everybody are the member of VLAN 1 by default. So I want to change the broadcast domain. So what I will do, I want to make these PC in VLAN 2 and these PC in VLAN 3. Again, same as VLAN 2, VLAN 3. So I will write it. Okay. I will write it here. This is VLAN number 2. This is VLAN number 3. VLAN number 2. VLAN number 3. So I have to create VLAN here first, and after that assign port specifically. So one thing you need to be in your mind, the ports that are connected to switch PCs, they are known as access port, and the port connected directly from switch to switch, it should be configured with trunk, so that we can transfer our VLAN database from one switch to another switch. Okay, so I'm going to configure on switch. Okay. First of all, I will erase this. Config. I will put the command VLAN 2, and I can put any name to this name. For example, HR department, exit, VLAN number 3, name, marketing department, exit. Okay, so if I will check now show VLAN, okay, then you will check there VLAN number 2 and VLAN number 3 is there. Okay, so VLAN number 2 and VLAN number 3 is there. So I have to put the ports in this. So I'm making data VLANs first. So I can put the range command here, interface range FA0 by 1 to 2, switch port mode access, switch port access VLAN 2. This is the command. I will put all the commands on notepad because the screen is short. Interface range FA0 by 3 to 4, switch port mode access, switch port access VLAN 3, do show history. So I'm going to copy these commands and I will show you on this board. So this was the VLAN number 3, and VLAN number 2, name HR, exit. This was the command that I have used on my first switch. So same as I have to put command, this is VLAN 2 and this is VLAN number 3. So now we don't need any range. Interface FA0 by 1, switch port mode access, switch port access VLAN 2. Okay, so if I'm not able to make the VLAN, then you can see access VLAN does not exist. It is automatically creating VLAN 2. So if I have not created VLAN yet, then automatically it will create VLAN if I will use this command. Switch port mode access, Now it will create VLAN number 3. Okay, so check in VLAN, show VLAN. 1 and 2 are the part of 2 and 3 VLAN respectively. And if I will check on switch number 1, then you can check 1 and 2 are the member of HR, 3 and 4 are the member of marketing. So the meaning of VLAN is now 1 and 2 will connect with each other. Okay. After that, I will hide it. This one will be pinged with each other, but they are not able to ping, and they are also not able to ping because the broadcast domain of the VLAN of the LAN is break. Now you want to ping VLAN number 2 on first switch to VLAN number 2 on second switch. So if you want to create a link between two switch, then you have to put trunk command in between the switch. So on first switch, the port F0/5 is connected with second switch. So I have put command switch port mode trunk. So switch port mode trunk command should be at least on one interface. There is no need to put trunk command on both the interface. You can put that command only to one interface. If trunk is enabled, then VLAN 2 is able to ping with VLAN 2 on another switch. And if now you are going to ping with broadcast ID, then only 2 and 5 will reply to you, because 2 and 5, they are the member of VLAN 2. And if you are going to start VLAN with VLAN number 3, then you can check ping 192.168.1.255. 4 and 6 will reply. So this is the method of VLAN, like you can break the VLANs. So the command used for switch port mode access, switch port access VLAN 2 is used for data VLAN. For example, I'm just taking an example. You want to apply voice VLAN here. So I'm just going to change this port into voice VLAN. Okay. Like interface FA0/4. The command is same, switch port mode access, switch port voice VLAN, for example 3. Now I have applied F04 with voice VLAN also. Like if you want to transfer voice from this link, then you can transfer. So this is all about the concept of VLAN. Thank you so much. Hello everyone. Our today's topic is about inter-switch connectivity. And first of all, we need to learn some theoretical concept before doing the practicals on Cisco Packet Tracer. So in inter-switch connectivity, we have to work on another encapsulations. Okay, so in inter-switch connectivity, first we need to learn about trunk ports again, like what are trunk ports. Second thing, what is 802.11 Q encapsulation, and what is a native VLAN. Okay, so in our last topic we have learned about VLAN, that VLAN is used to break the broadcast domain. If we have same network IDs, PCs are connected with each other with the help of switch, then we can break the broadcast domain and we can make logical grouping of the PC that are connected to switch. Okay, and trunk ports are used to transfer VLAN database, from one switch to another switch. Like for example, I have connected 3 switch, and on first switch I have used VLAN 2 and 3, and on another switch I have again VLAN 2 and 3, and again VLAN 2 and 3. 2, 3, 2, 3, 2, 3. So if you want to ping with 2, then you have to put trunk port here, like transfer the VLAN database. And one more thing, if for example here is VLAN number 4 and here is VLAN number 4, but there is no VLAN number 4 on second switch, then we have to put the VLAN tag here. VLAN tag here means like we have to make manually VLAN 4 here, so that VLAN 4 can communicate with VLAN number 4. Even we don't have any PC assigned to VLAN number 4, So with the help of trunk, we can transfer our database from this port to another port. And in second part, we have encapsulation named 802.11q. Okay, so this is the encapsulation given by IEEE, and this encapsulation is used when switch is going to connect with different broadcast domain. For example, 10.0.0.1, 10.0.0.2 here, 20.0.0.1 and 20.0.0.2 here. Okay, so if you want to ping these 10 and 20 on the same switch, and already they are on VLAN 2 and VLAN number 3, so I will use multi-layer switch or router, and we can transfer our database from this port to this port with the help of 802.1q encapsulation. And at last, we have one VLAN, that name is native VLAN. Okay, native VLAN is simply one VLAN which traverses a trunk port without a VLAN tag. Like we don't need to tagging with the VLAN, we can use specifically native VLAN here. So this is the part of inter-switch connectivity in which we need to know about native VLAN 802.11q, like dot 1q. Actually, the encapsulation name is 802.11 means standard, but 802.1q means dot 1q encapsulation, and after that there is a trunk port. Okay, thank you so much. Hello friends, our today's topic is about inter-switch connectivity practical. Okay, in our last video we have discussed about trunk ports 802.1q and after that native VLAN. So in our today's practical, we have to go with the different broadcast domain, and after that we have to connect that broadcast domain. So to connect with the two broadcast domain, we can use multi-layer switch as well as we can use a router also. So in switching we are using already switch and multi-layer switch. So in this practical I am preferring router here. So I am going to connect the switch with router also. So first of all, in inter-switch connectivity, what I have to do, I have to put these two switch in these two PCs in VLAN number 2 and these two PCs in VLAN number 3, and besides this I have to put these VLAN number 2 network is 100.0.0.1/29, sorry 100.0.0.0/29, and it is my 200.0.0.0/29, like with different broadcast domain by default. Okay, so I will write it in Cisco Packet Tracer. I have a sticky notes here. So this is the network of 100.0.0.0/29, VLAN number 2, 200.0.0.0, VLAN number 3. So first of all I have to create VLAN first. So VLAN number 2 and VLAN number 3. So what I have to do, enable config. Okay, so in this I have to put the command VLAN 2 and I have to give name. Name is optional. If you don't want to give name, then it is also okay. So I am not putting any name here. I am putting VLAN 2 and VLAN 3 simply. So if you will check this do show VLAN, then you can check VLAN 2 and VLAN 3 with their default name is already made on the switch. Okay, so in our last practical we have done this, that we can use interface range, FA 0/1 to 2, switch port mode access, switch port access VLAN 2, and interface range F0/3 to 4, switch port mode access, switch port access VLAN 3. And don't forget to make the trunk link because F05 is directly connected with router, so we have to make this as a trunk port. So interface FA0/5 switch port mode trunk. Do show history. You can check history here. Okay, so our switch part is done, and you can check. I forgot to give the name. Sorry, 100.0.0.1, 255, 255, 255, 248. Because IP address I have to give. Okay, 100.0.0.6 is my gateway. 100.0.0.2, 100.0.0.6 is my gateway. 248. So on the next species, 200. So 200.0.0.6, 200.0.0.2. I forgot to give the IP address as very first place, but you have to give IP address at very first time. Why? Because after designing you have to follow the module IP addressing. 200.0.0.6. Okay, so now they are pinging with each other, 100 and 100 ping with each other, 200 and 200 ping with each other. But we have to make inter-switch connectivity, so we have to ping 100 and 200 with each other. So for this I have to use encapsulation 802.1q. Okay. So I'm going to click on router. So I have to use here concept of sub interface, because I'm not able to give two IP address to one interface. So if I am able to give secondary IP address to this interface, then I am not able to ping two VLANs with each other. So that's why I have to use here FA0/0 with no shut command, and after that I have to use here interface FA0/0.1. You can choose any number range up to 4.29 billion. So I'm choosing 1. Okay. So if you are going to give sub interface here, then the main requirement of this interface is encapsulation. Why? Because you are not able to give IP address to sub interface. Okay, if you want to try, I will try to give IP address 100.0.0.6, 255, 255, 255, 248. Then they will provide you an error like configuring IP routing on a LAN subinterface is only allowed if that subinterface is already configured as a part of IEEE 802.10, 802.1q and inter-switch link VLAN. So we have to use encapsulation.1q here and VLAN number 2. So then if we are going to give IP address, it will be taken by the port. So F0/0.2 encapsulation.1q3 and the IP address should be 200. Do show history. So you can check you have configured sub interface IP with encapsulation.1q command. So now what switch will do? 100 with the help of sub interface can ping with the router. 200 also can ping with the router, and after that you can specifically ping 100 to 200. First packet is failed and after that second packet is successful. But if you want to see the route from 100.0.0.1 to 200.0.0.1, you can capture the packet. You can check the ping is done by router, not with the switch. So this is known as inter-switch connectivity with 802.1q encapsulation. Thank you. Hello guys, our today's topic is about layer 2 discovery protocols. So in layer 2 discovery protocol, we have to discuss about CDP and LLDP. Okay, so first of all we need to know about these two protocols. Basically these are known for the neighborship protocol. Okay, so first of all, I'm going to discuss about CDP, and the full form of CDP is Cisco Discovery Protocol. Okay, so Cisco Discovery Protocol is a Cisco proprietary protocol that is used for like collecting directly connected neighbor device information like hardware, software, device name, initials, and many more. And in CDP we have two versions like CDP version 1 and CDP version 2. So we have two types of version in this. So what is the difference actually? The initial version, which is capable only to collect device information connected to next end. Okay, so this version is used for collecting the information directly connected device to the direct end. While if we talk about CDP version 2, in CDP version 2, it is the most recent release of the Cisco protocols. It provides more intelligence device tracking. Okay, like for example, you want to track your interface, you want to check that your VLANs are mismatched or your trunk links are up or not, mismatch in duplex state. So CDP version 2 is better than CDP version 1. While if we talk about the another protocol here, which name is LLDP. So LLDP is also a protocol which is similar to CDP, but in LLDP it is known for layer 2 discovery protocol. So it means it works on the switches. Okay, the big difference between the two LLDP and CDP is that LLDP is a standard while CDP is a Cisco proprietary protocol. Like you can say that Cisco device support the IEEE 802.1 AB versions of LLDP, and this allow non-Cisco device to advertise information about themselves to our network device. So it is the difference between LLDP. Now I have to move on to the practical part, that in practical I have to check on Cisco Packet Tracer how it will work. So I have to erase all the commands here. Okay, so in this hope this is seen by you. So I will just use the Cisco Packet Tracer here. Okay, so I have for example two 1841 router, and these 1841 routers are connected with each other. So first of all I am going to provide IP address here like no enable config. Okay, interface F is 0 by 0. IP address I am giving it to 10.0.0.1. I am using classful network just to check about the CDP. And on another router I am going to use it no enable config, no enable config, interface F is 0 by 0, IP address 10.0.2.0.0.0. So how CDP will work here? So you want to check, then you can use the command here. So you can check with the command show CDP and after that question mark. For example, you want to check the entry information for specific neighbor entry, then you can use entry. If you want to check the interface information or status or configuration, you can use show CDP interface. Otherwise, you can go for show CDP neighbors. So if I will check show CDP neighbors, then you can check the capability codes. If we have connected routers with each other, then it will show that router is connected, the platform is this, and the local and the port ID interface is fast Ethernet 0 by 0. Okay, so hello time for CDP is 60 seconds and hold time is for 180 seconds. So it is showing 152 this time. Okay, show CDP interface. If you will check show CDP interface here, in show CDP interface you can check the time. 60 seconds is the like sending time, hold time is 180 seconds, and also you can check here like interface information, protocol is up or protocol is down. And show CDP entry, show CDP entry star is let you know about the duplex is full and what is the version you are using Cisco images. After that, what is your IP address and everything that you need to know. Okay, so this is CDP and link layer discovery protocol information. Thank you so much. Hello guys, today we are going to discuss about layer 2 and layer 3 ether channel. So our topic is ether channel. Okay, first of all we need to know about like what is ether channel and what we have to discuss about LACP here. Okay, ether channel is supposed to be the logical bundle of physical redundant link between switches. Redundant means duplicate links. Like for examples, this is a switch, this is a switch, and switches are connected like this. Redundant links between the switches are connected like 4 cables. It may be layer 2, it may be layer 3, so you can choose like this also. So if you are seeing that there are the physical link connected between two switch and you want to make it as a logical bundle, okay, like 4 links are converted into one single link, so this is known as ether channel. Like to create a logical bundle of physical redundant links between switches is known as ether channel, or you also called it as like aggregations of the links. Okay, so after aggregation we have to go for the practical part, but before the practical part we need to understand the concept used by ether channel. And Cisco has one version of ether channel which named as PAGP, port aggregation protocol, which is used by Cisco, but now we are working on LACP, link aggregation control protocol. In link aggregation control protocol we have 2 modes, active mode and passive mode. So it is working like same as in the previous version of Cisco, that in PAGP we were working on desirable and auto mode. So the work is done in PAGP as desirable, same work is done by active mode, and the auto mode for PAGP same represent the passive mode in LACP. So let's have some practical. So I have to open my Cisco packet tracer first. On Cisco packet tracer we will configure our ether channel. So this is our Cisco packet tracer software. So I will enlarge the size of Cisco packet tracer and after that we will configure it. So you can use it for both layer 2 and layer 3 switch, it's up to you. For the current time I am using 2 layer 2 switches here and I am connecting 1, 2, 3 and 4. So I have connected 4 links between 2 switches. So you can see that by default one switch ports are green and another switch ports only one port is green. This is because of spanning tree protocol, because spanning tree protocol is used to avoid the loop between 2 switches, so that only one port is open at one time. Okay, so now it is used for loop avoidance. So I want to use as a link aggregation control protocol. So what we have to do, I have to go for the CLI command, and in CLI enable configure interface range FA0 by 1 to 4, because we have taken 4 links, and switch to switch the mode should be configured as a trunk, because trunk is configured between 2 switches. And now I am going to make 4 links into one bundle, and the command is channel group. So we can choose 1 to 6 channel group 1 mode. So I have told you that in LACP we have 2 modes, active mode as well as passive mode. So I'm using this mode as a passive. So what is the meaning of passive? Passive means I will enable LACP only if a LACP device is detected. So make sure if you are using one mode as a passive, then another mode should be active also. Okay, so I am going to exit this. Interface port channel 1, switch port mode trunk, and I have used the default VLAN, so I have to allow that VLAN. Switch port trunk allowed VLAN 1 here. Do show history. So this was the command that I have used in my switch number 1. So you can check here. First I have used 4 interface, and after that I combined it into one mode passive, and after that interface port channel will be up. So on the other hand of switch, click on switches, enable interface range FA0 by 1 to 4, switch port mode trunk. Okay, so channel group 1 mode active. So in our first switch we have used the mode passive, and in our this switch I'm using active. Exit interface port channel 1, switch port mode trunk, and switch port trunk allowed VLAN 1. Okay, so you can check here now both the ends of switches are green, and if you will check here like show ether channel, in show ether channel you will check group is 1, that I have chosen port channel 1 here. Group state is L2 because I am choosing here layer 2 switches. Port is 4, but you can access maximum port 16, and the protocol name is LACP. So LACP is the ether channel form which is used for like the logical bundle creation of physical redundant link. Thank you so much. Hello friends, after completions of layer 2 protocols, ether channel, layer 3 protocols, we have to discuss about one important protocol which is known as RSTP, Rapid Spanning Tree Protocol, and it is the version of STP, Spanning Tree Protocol. So Spanning Tree Protocol is the basic version and RSTP is the Rapid Spanning Tree Protocol. Rapid STP. Okay, first of all we need to understand like what is STP. So spanning tree protocol is the layer 2 protocols which is by default enabled between the switches. Okay, so what is the work of STP? It is used to avoid the loop between switches. Okay, so this protocol is used to avoid the loop between switches, like how loop is made between the switches. Okay, for example, we have to switch and we have some redundant links between switches. Okay, so STP will work like 1 port, 2 port, 3 port are sending information to another switch. For example, it is just an example. So what is the behavior of the switch? Switch receives information from one port and send from another port, receives from this and send from this, receives from this and send from this. So STP, what STP will do? It will do some election and it will use only one port active at one time and another 2 port will be in the blocking state, so that I can use only one port and data can be transferred. So packet will not do like this. This is the process of loop. So to avoid the loop we use spanning tree protocol, and rapid spanning tree protocol is the version of spanning tree. Okay, so this is the basic description for STP. So to understand STP or RSTP, you need to understand the basic terms of your spanning tree. First of all, you need to understand about root bridge, and after that non-root bridge. Okay, Third part, you need to know about what is BPDU, what is your port cost, what is your bridge ID, and what is your path cost. Okay, for example, I have 4 switch here. Okay, so in 4 switch, all the switches are connected with each other. Sorry. So which is becoming the root bridge in this? So the root bridge concept is the lowest bridge ID. Lowest bridge ID. So first of all, we need to learn about bridge ID. Okay, so bridge ID is the combination of bridge priority, which is by default same on every switch is 32768 plus base MAC address. Okay, so it is the theory topic. Okay, base MAC address. Now, for example, its MAC address is A, B, C, and D. So how STP will work here? So the lowest MAC address is of A because priority of every switch remains same. So the election is based on switch. Sorry. So this is your root bridge. So root bridge is the best bridge. The port of root bridge is always designated port. Okay, these all switches are known as your non-root bridge, and BPDU is known as bridge protocol data unit, like the subsequent information sent from one port to another port is BPDU. Port cost is by default defined by IEEE. Okay. So the port cost is, if you are using Ethernet, then the cost is, Ethernet port cost is 100. Fast Ethernet cost is 19. Giga Ethernet cost is 4. And 10 Giga Ethernet is 2. So by default we are using switches with fast Ethernet and Giga Ethernet. Okay. So if you, okay, I will erase it first. If your switch is connected to another switch with fast Ethernet, okay, then the cost should be 19. If your switch connected to another switch with Giga Ethernet, then your cost is 4. Okay, so the less cost will be better use. Okay, the path cost is, for example, we have again these 4 switch. This is my root bridge because it has lowest bridge ID. These are non-root bridge. So every port, every non-root bridge has one port which named as a root port. Root port is their best port to reach root bridge. Like 19, 19, 19 is the cost here. So for this switch to reach root bridge, 19 cost. So this is the root port. So for this switch to reach the root bridges, this is the root port. Now for this switch, the cost is same from the both side, 38. Okay. So if it is 38, then switch will do the election based on their respective MAC addresses. For example, this is A, this is B, this is C, and this is D. So this port should be the root port because the MAC address of this switch is lower than this switch. So after that, this port should be blocked port. So it is used to avoid the loop. And the cost from one port to root bridge, the total cost to reach the root bridge is known as path cost. So this is the basic version of STP. Thank you. Hello everyone. In our last video, we have discussed about basic STP and rapid spanning tree protocol. Like we have discussed about the STP terms, in which we have discussed about what are the root bridge, non-root bridge, BPDU, and how STP will work. So our next topic is STP ports. Okay, so we have port number 1 is known as designated ports. Designated ports are always forwarding ports, and all the ports are designated of root switch. Root switch means root bridge. So designated ports are those who can send the information and who can receive the information at one time. So root bridge, all ports are designated. The second term is the root port. Root ports are basically made on non-root bridges. Non-root bridges, and non-root bridges best port, the best port with best cost to reach root bridge is known as root port. It can also be forwarding and it can also receive the information. The third port named is blocked port. So blocked port are the ports those would not forward frames from their interface, they can only receive the information. So these are the STP ports. Besides this, we have another ports like backup port, we have alternate port, but that ports are secondary ports. Mainly if you go for the practical work of STP, then you will find these ports. Besides this, we have STP states and rapid spanning tree protocol states. First we will check spanning tree states. We have disable state, blocking state, listening, learning, and forwarding. Okay, in STP these three states are converted into discarding state. Like RSTP is rapid spanning tree protocol, so the first three states are known as discarding state. The last two states, learning and forwarding, are same in RSTP. Okay, so first we need to understand about the states. The total STP convergence time is 50 seconds. Okay, so in which 2 seconds is the hello timer, and listening will take 15 seconds, learning will take 15 seconds, and the process from disable to blocking or disable to forwarding, it will take 18 seconds extra. So 18 plus 2, 20, 20 plus 15, 35, and 35 plus 15 is 50. The total STP convergence time is STP. So this is the states of STP. Now, after the states, we need to know about one basic concepts in spanning tree protocol, which name is port fast. So port fast is the key term used in our spanning tree protocol. Basically, port fast feature is enabled, used to connect only single workstations to avoid the loop. Like in port fast, the benefit of port fast is this: it bypass our listening state, like 15 second, learning state, and automatically bypass all the states into forwarding state. So port fast feature is used to bypass the listening and learning state in STP. Thank you so much. Hello guys, today we are going to discuss about the Cisco wireless architecture, in which we have to discuss about the various wireless architecture. So in first, you can check, we have example of autonomous AP architecture, in which you can check core layer, distribution layer, access layer, and autonomous APs. Okay, so why we use what is the use of this autonomous AP architecture here? In autonomous AP architecture, it is like a self-contained device with both wired and wireless hardware, so that it can bridge to a wireless VLAN infrastructure, wireless clients that belongs to service set identifier. Okay, in which this diagram you can check, each autonomous AP must be configured with a management IP address so that it can be remotely accessed using Telnet or SSH, or you can use any web interface to connect this. So each autonomous AP must be individually managed and maintained unless you use management platform such as Cisco DNA Center. Okay, so it is all about autonomous AP architecture. Okay, so in our next diagram, you can check cloud-based AP architecture. So this is known as cloud based. Okay, what is the difference between autonomous AP and cloud based AP? Because all the connections are like this. In cloud based AP management, it is an alternative to purchasing a management platform. Okay, in this the AP management function is pushed onto the internet cloud. Like we can check, for example, Cisco Meraki is a cloud based AP management service that will allow you to automatically deploy Cisco Meraki AP. So at next we can discuss about WLC, lightweight AP architecture, LWAWP. In this you can check WLC is connected with switch and switch is also connected to router. So in lightweight AP it is different from autonomous AP as well as it is different from cloud based AP. And the next example of our architecture is split MAC architecture. So it is also used as a wireless architecture. So this is all about our like Cisco wireless architecture. Thank you. Hello everyone. Today I'm going to discuss about wireless component, and you call it as WLAN component also. Okay. So what are the wireless components which are used in the process of WLAN? Okay, so here you can see we have components like printer. As you know that printers are used to print anything, like if you want to print your information from Wi-Fi device, you can print with the help of printer. Mobile phones are usually connect with our Wi-Fi. Okay, mobile phones are used to connect with another person if you can call via Wi-Fi or via cellular network also. In WLAN components you can also use laptop. Most commonly used devices are laptop and desktop PCs. Okay, in desktop, some of the desktop PCs we don't have WLAN device like WAN interface card. So if we put WAN interface card in desktop PCs, so also we can connect it with WLAN. Okay, so data collector is also a WAN component. Dex phone you can also connect used for WLAN, and personal digital assistance is also used for WLAN components. And besides this, for WLAN components we have the device name access point. So access points are basically used to like connect these devices with each other with the help of radio techniques. And after that you can use wireless routers also. The difference between access point and router is only that in routers we can put more security than access points. And after that, in that same as access port and trunk ports are also used, provides for information from one interface to another interface. So this is all about WLAN components, because in our next video we are going to configure how to configure WLAN device, how to configure router, and how to access any Wi-Fi router with the help of Telnet and SSH. Thank you so much. Hello everyone. Today I'm going to discuss about wireless component, and you call it as WLAN component also. Okay. So what are the wireless components which are used in the process of WLAN? Okay, so here you can see we have components like printer. As you know that printers are used to print anything, like if you want to print your information from Wi-Fi device, you can print with the help of printer. Mobile phones are usually connect with our Wi-Fi. Okay, mobile phones are used to connect with another person if you can call via Wi-Fi or via cellular network also. In WLAN components you can also use laptop. Most commonly used devices are laptop and desktop PCs. Okay, in desktop, some of the desktop PCs we don't have WLAN device like WAN interface card. So if we put WAN interface card in desktop PCs, so also we can connect it with WLAN. Okay, so data collector is also a WAN component. Dex phone you can also connect used for WLAN. and personal digital assistance is also used for WLAN components. And besides this, for WLAN components we have the device name access point. So access points are basically used to connect these devices with each other with the help of radio techniques. And after that you can use wireless routers also. The difference between access point and router is only that in routers we can put more security than access points. And after that, in that same as access port and trunk ports are also used, provides for information from one interface to another interface. So this is all about WLAN components, because in our next video we are going to configure how to configure WLAN device, how to configure router, and how to access any Wi-Fi router with the help of Telnet and SSH. Thank you so much. Hello everyone. In our this video we will discuss about AP and WLC management access connection, like how we can connect with our devices. So in this process we have to discuss about the types, like first of all we can connect with the help of Telnet, and second we can connect with the help of SSH. Via HTTP or via HTTPS we can also connect. Console, with the help of console we can connect, and with the help of TCAS and radius server we can also connect with, and we can manage our WLC. Okay, first of all, what is a Telnet? Okay, Telnet use port number 23. Basically it is used for the remote connectivity. Okay, by default in each and every router, if we talk about routers or wireless device, in this virtual teletype is used. So with the help of Telnet you just provide IP address in your command prompt, and you can type Telnet and the IP address for the physical router, and if you want to connect Wi-Fi device then directly you can access. And next part is SSH. SSH is secure shell. The port number of secure shell is 22. It is same as Telnet, but it is highly encrypted. So you can say like it is more secure than Telnet, because the password is protected in SSH. After that your data is also protected in SSH. Okay, besides this we have two new types, like HTTP port number 80 and HTTP port number 443. If you want to access your router with the help of a web browser. So in web browser, like for example, you have to type here http:// and your IP address like 192.168.1.1. Or if you want to use secure connection, packets encrypted, then you can use HTTPS access. After that you can directly connect your device with console cable, because with the help of console we can also configure our device. And at last we have TCAS and radius server. Basically these servers are used to provide the security, like with the help of simple password we can connect, but with the help of these server, TCAS and radius server, in this AAA technique is also used. Okay, in which authentication authorization technique is used, and also you can protect your device with username and password. So this is all about WLC management access connections. Thank you so much. Hello everyone. Our today's topic is all about the practical configuration of wireless router. So in this video we will configure practically our WLAN device, or you can say wireless access routers for client connectivity. Okay, so first of all we need to learn about the basic things, like for configuring a wireless router or your Wi-Fi router, what are the things that are needed for us. So first thing that we need is public IP address, which is known as WAN IP address or internet IP. Second is your private IP address, and third is your Wi-Fi name, which is called as service set identifier. and fourth thing is named as password. So password are also two types, WEP wide equivalent privacy and WPA wireless protected access. In WEP wide equivalent privacy there is a less security, but in WPA we have more security of our wireless device. So let's start with wireless configuration. So I'm going to move on to Cisco Packet Tracer. Here we have design. So just for example, feel it like this. This is my ISP which is going to provide us internet. So this is my wireless device here. So first of all, to configure Wi-Fi, I have to configure my ISP interface. So I'm just going to show my port labels. So I'm going to give IP address to fast Ethernet F0/1, which is connected to switch, and the IP address is 200.0.0.1, 255, 248 because two PCs are connected there. So it is no shit. And also I'm going to provide F0/0. F0/0 is the IP address which is going to connect with you on the wireless router. So I'm using here IP address 100.0.0.1/30. Okay, so F0/0 IP is 100.0.0.1, 255, 255, 255, 252. So this is the public link for your Wi-Fi. Okay, so it means if you are going to configure wireless router, then your public IP range is 100. Okay, so I'm going to give IP address to the PCs 200.0.0.2, 200.0.0.1. Okay, 248, 200.0.0.3, 0.0.1. Okay, so the LAN interface is configured. Okay, now move on to my Wi-Fi device. So for connecting Wi-Fi, we need laptops, we need PCs or anything. But first of all, if you are going to configure this, go in graphical user interface. So you can connect your wireless device with three types automatically. DHCP, if I will configure DHCP here, then you don't have to configure your Wi-Fi public IP address. And you can go with PPOE. Many companies provide usernames and passwords, so you can go at this. But today I have to configure my wireless device with static IP address. So my IP address is 100.0.0.2. Gateway is 255, 255, 255, 252. Sorry, this is the subnet mask, and gateway is 100.0.0.1. If you have DNS, then you can choose DNS. Otherwise, let it be for this task. So here you can see network setup, router IP. So this is my wireless router IP address, which is already configured with 192.168.0.1, and 255.255.255.0 is the subnet mask for this. So this is your public IP. This is your private IP. Let's save this configuration, and after that go to the another wireless tab. You can give here network name, like for example XYZ Wi-Fi here. So save setting, and the wireless security is WPA2 XYZ@RAJWV. I'm giving password like XYZ@Rajiv. Okay, so save this setting. Now all the four things are configured in my Wi-Fi. So if all the things are configured, so this is now it is ready for the connect with laptops and computer. So but in Cisco Packet Tracer you have to do one thing. You have to remove the physical LAN interface and add here wireless port on, and same as in our PC, like if without changing the port you are going to access, it will be provide error. Then in physical, off the interface, remove this interface and add the wireless interface here. Okay, now click on PC wireless, connect. You will get here XYZ Wi-Fi connect, and I am putting the password xyz@Rajiv connect. So you can check with the help of radiations, it is going to connect with Wi-Fi device. XYZ Wi-Fi connect, password connect, and private IP address is automatically assigned to this, and public IP address is assigned on wireless router. And the main and important thing is this: when you are going to connect your Wi-Fi laptop with outside, it is successful. Okay, first time ARP entry is used, so packet is failed. Okay, now you are pinging from inside to outside. It is pinging, but you are not able to ping outside to inside because inside the network is private network. So you can ping from your private network to public network, but any public person cannot able to connect with your private network. Okay, so in this we can provide securities also. If you want to provide firewall security, or you want to any restrict your any website, you can give it here the URL like facebook.com, google.com and another thing. And if you want to change your router password admin into another, then you can also choose this, and after that you can check the status of your router. So this is all about wireless router configuration. Thank you. Hello everyone. Our today's topic is about IP connectivity. At last we have done with our two modules, network fundamental and network access. So in this module we will learn about IP connectivity. So our first topic for today is, what is the component of routing table? Okay. So first of all, we need to understand what is routing table and what is the process of routing actually. So routing is the process of path determination from one port to another port and one network to another network. Hope you remember about LAN and WAN. I told you about that WAN works on different network ID. So in WAN works on different network ID. So different network connectivity process is renamed as routing, because switching is the process of LAN connectivity and routing is the process of WAN connectivity. So how routing table is made and what are the components used in routing table? So first of all, if you will see routing table, in routing table you will find something like, first of all you will find a routing protocol code. Okay, in second time you will find what are the prefix. Okay, what is your network mask, what is your next hop, what is your AD value of router administrative distance, what is the metric, and what is gateway of last resort is not set. Gateway of last resort. Okay, so one by one we will discuss about it. In routing table, routing protocol codes represents you which type of routing you have used in your topology. Like if you will choose static routing, then the protocol code will be S. If RIP routing will be used, then R will be the code. For EIGRP, D will be the code. For OSPF, O will be the code. For BGP, B will be there. Like routing protocol represents which routing you have used. Second thing is prefix. Prefix is like your network ID. Like for example, my network, this is my network. I will make a design again. For example, this is router, this is router, this network is 10.0.0.0, this network is 20.0.0.0, this is 30 network. So if I will check routing table of R1, then C stands for connected, 10.0.0.0 and 30.0.0 will be the connected routes. For example, I am choosing static routing. So S code with 20000. This process, this is known as your prefix, and after prefix there will be one value after slash. For example, /29 here. /29 means the network mask, means subnet mask, which subnet mask you are choosing in this. And after this network and network mask, for example prefix and prefix mask, you will check like via 30002. 30002 is the IP address of next hop. So the value 30002 represents here next hop, like from where our data transfer from 10 to 20. And if I am going to choose with for example RIP R, for example OSPF, then O, D stands for dual algorithm EIGRP, then every dynamic routing protocol has one value named metric. Metric is the criteria to find the best route. Okay, so metric, when you will check static, then in static you will check direct AD value of 1 and no metric here, because it is definitely it is static route, like manually configured route. But in RIP the metric is hop count, OSPF metric is cost, EIGRP metric is K values. So when you will check RIP, OSPF or EIGRP in our practical, in our next videos we will do the practicals about these protocols. Okay, so you will check the metric value here, and the AD value for static routing is, AD is the administrative distance, like it is the logical prefix, you can say logical value, or you can say logical distance from one interface to another interface. RIP AD value is 120, it is fixed. EIGRP internal AD is 90 and external AD is 170. OSPF AD is 110, static route AD is 1. And at last you can check when gateway of last resort is not set. Mainly you will check gateway of last resort is not set, because this gateway of last resort is your next hop value. It is only enabled when you will work on default routing, and in default routing you will mention IP route and its gateway. So this is all about the component of routing table, and practically we will discuss when we will do the practicals of IPv4 and IPv6 addressing. Hello everyone. In this video we will discuss about and we will determine how a router makes a forwarding decision by default, because in our last video we have discussed about routing table. So in this theoretical video we will discuss about how router will forward our route by default. So by default which process will be used, you have to check. Okay, so in routing table it will use 3 process. First of all it will check its longest match, and in second process it will check AD value, and in third process it will check its routing metric. Okay, so I will let you know by an example. These are the 3 things. First you need to understand about it, what is longest match, what is AD value, and routing metric. Longest match is like what is the slash value you are using in your routing table. You are using /30, 29, 27. It is all about the subnet mask that you have chosen. So highest prefix length it is chosen. For example, a router wants to choose by default route, so it will check highest prefix length. For example, this is the router and it has 3 routes. So first, if the value of /30 is equal, so it will not take decision up to longest match, it will take the decision based on AD value. Now for example, in our this part I'm using RIP. By default I'm using RIP. So the AD value of RIP is 120. So if the value of AD is remains same, so it will not take the decision based on AD value, it will go to routing metric. Okay, so now for example I am taking example of RIP. So RIP's metric is hop count. Okay, hop count. Now for example from this side it will take 3 hop to reach, from this side it will 4 hop, and for this side it will take 5 hop. So the less cost path will be your primary path and another are your secondary path, and these values are changed according to your protocols, because in RIP your AD value is 120. If you change AD value, then you can transfer your route, you can forward your route according to AD. By default it will take hop count metric. If you will choose EIGRP with same AS number, 90 is AD value and K value is the metric, like bandwidth, delay, load, reliability, MTU means maximum transmission unit, so it will check 5K values. And third part is OSPF, open shortest path first. AD value is 110 and cost is your metric. So cost is basically 100 divided by link bandwidth. So the less cost will choose the path. So this is the how router makes their forwarding decisions with the help of AD value, with the help of routing metrics. Thank you so much. Hello everyone. In this video we will discuss about practical version of routing. So we are going to discuss about IPv4 and IPv6 routing, and after this we will discuss about dynamic routing also. But first of all we need to understand the concept of routing. So routing is the process of path determination from one network to another network. So if we talk about static routing, even it is for IPv4 and even it is for IPv6, the main motive of static routing is in which all the actions are done through the direct action of administrator. Okay, like all the action taken by administrator only, so it is called static routing. So in this I have to make a design on Cisco packet tracer. So come for the practical part. So I'm taking 2 router here, and after that 2 switches. You can take 2, 3, 4, 5, 6, any design, up to you. It's up to you that how many routers you want to take, how many switch you want to take, it's up to you. So you can choose fast Ethernet cables for connecting with router to switch, which is known as straight cable. You can choose cross cable in between routers, or you can choose this serial cable also. So it's up to you that you want to choose serial cable or you want to choose fast Ethernet cable. So I'm using serial cable here. Now for example, I have network ID here 10.0.0/29, 20.0.0/29 and 30.0.0/29. So first of all I have to configure the PCs like 10.0.0.1, 255, 255, 255, 248, because we have represented /29. That's why 248 subnet mask. 10.0.0.2, 10.0.0.3. The IP addressing module we have done in last videos also. 20.0.0.1, 20.0.0.3 should be the gateway, 20.0.0.2 and 20.0.0.3. Okay, so now I'm going to configure about router. So first of all you have to make design, and after that you have to go for IP addressing. Okay, so interface fast Ethernet 0 by 0. IP address 10.0.0.3, which is the gateway for LAN 1, and also interface serial 0 by 0 30.0.0.1, but here we need only 2 IP, so I can choose 252 here. Okay, so this is the design configuration for router 1. Now move on to router number 2. So interface serial 0/0/0 30.0.0.2 255 255 255 252, and interface fast Ethernet 0/0 20.0.0.3, because it is the gateway for second LAN. There is a space. So IP addressing is done. Now router 1 has two direct network 10 and 30. We can check it in this show IP route. And routing cable components we have discussed in the last videos. These are the codes, these are the prefix, this is the prefix length, this is the port that is attached to our router. So now I have to configure static routing here, because in second router if we will use this command, then 20 and 30 are the direct network for router 2, 10 and 30 are the network for 1. So for static IPv4 routing, I have to use command IP route. So indirect network is 20.0.0.0 and space 255 255 255 248 subnet mask, and I have to check next hop here 30.0.0.2. So in static routing we have to mention indirect network ID, subnet mask, and next hop IP address. On the second router we have to configure IP route 10, because indirect network ID is 10 255 255 255 248 space 30.0.0.1. Either you can choose next hop IP address, either you can choose exit interface here, so it is up to you. After configuration of static routing, you can also check show IP route. You will get the network, indirect network with the ID value of 1 via 30.0.0.2. So now routing is done. So if you want to ping 10.0.0.1 with 20.0.0.1, then first packet will fail because due to ARP entry, address resolution protocol, but after that IP is successful. Sorry, ping is successful. So it is all about IPv4 static routing. Thank you. Hello everyone. In this video we are going to discuss about IPv6 static routing. So in our theory part we have discussed about IPv6, like what is IPv6, how to configure IPv6 address. Now I have to ping with this network, with this network, with the help of static route. So in last video we have configured IPv4 static routing. Now we are going to configure IPv6 static routing. So for IPv6 static routing, first we have to go for IPv6 addressing first. So like here you can see that we have the range of IPv6 address 2010, here 2001:10, 2001:20, and 2001:30. So first of all we have to configure this. So after configuration of this we can do the static routing. So 2001:10:1 / I'm using 112, 2001:10:3 is my default gateway. So I'm choosing 2 here and 112, and gateway is 10.3. Here I'm using 3.1, 30, 112, and gateway should be 30:4 because I'm using 3 PCs. So I just want to give IP address 1, 2 and 3, 4, and at last PC I'm going to configure IPv6 address 30:3, and 30:4 is my gateway. So when you are about to configure router, then just make sure one thing, that you have to use IPv6 unicast routing command, because by default IPv6 routing is disabled on some Cisco routers. So after that you can configure IPv6 address 2001 10:3/112, no shutdown. Interface serial, sorry, I am using only fast Ethernet. So F0/1, here I am using 20:1, no shutdown. So this is configured. So on second router, FA0/1, so first IPv6 unicast routing, FA0/1 IPv6 address 2001 20:2/112, and FA0/0 is the IP address for 30:004 because it's the gateway for the LAN 2. Okay, so here you can see now all the IPv6 addresses are configured. Now IPv6 static root time. So command is IPv6 root. First you have to identify the interface prefix / prefix length space next hop IPv6 address. So this is my indirect prefix length and next hop IPv6 address. On router number 2 I have to use IPv6 root 2001:10:112 space 20:1. Okay, so I don't have to use with the next hop IPv6 address /112. So IPv6 static routing is configured. So to verify this, I'm using show IPv6 root. So in this you can check C stands for connected network, L stands for local, and S stands for static. So if static is there, so now you can ping from your command prompt 2001 30:1. So you can check it is pinging from this PC, and first packet is not failed in IPv6 routing because there is no use for ARP, because MAC address and IPv6 address both belongs to hexadecimal. So this is all about IPv6 static routing. Thank you so much. Hello everyone. In this video we will discuss about default routing. Default route, like what is default route? In our last video we have discussed about static route. In static route we have to configure indirect network ID and subnet mask and next hop IP address. But default routing is little bit different from static routing, because in default route one address is already used and it is reserved for default routing 0.0.0.0. This we have discussed in LAN and WAN topic also. So for network part and for subnet mask we will use 0.0.0.0 only, and but we can do this practical for next hop IP, or we can do this practical with exit interface. So I am going to configure both the practical on same design, but I will start with the practical of default routing with next hop. So already you can see we have configured already their network 10.0.0.1, 10.0.0.2, and also we can check This is the last vertical. We are not able to ping with another network. Destination, host, unreachable. So I have to configure default route on router number 1 and as router number 2. Okay. So config. So default routing command is IP route 0000 and next hop IP. So my next hop IP is 30002 because the next IP from my side. On router number 2, I have to use command IP route 0000 Okay. So when you configure this, then in show IP route you will check S star. Now star stands for candidate default and S stands for static. So it is known as default static route. So default static route, now this is 20001. I just want to ping 10001 here. So first packet will fail due to ARP entry that I have discussed in last lecture also, and another packets are successful. So this is known as default routing. Thank you. Hello friends. In this video we will discuss about network route and host route in static routing. So instead of Cisco Packet Tracer, I am using GNS3 software because in Cisco Packet Tracer it is not possible to provide /32 subnet mask. So that's why I am using here 3725 series router, second router. So after that I can choose here, okay, I will take 3 routers, not an issue. So I'm going to use here only fast Ethernet cable. So the network should be, my on network is 10.0.0/30 and 20.0.0/30, and here I'm going to use one loopback address which is used for host IP 3.3.3.1/32. So /32 means it is a host, okay, and now I'm going to use, first of all it is going for up the routers, like play with play button you can on the GNS3 software. So first of all, when I click on R1, I have to configure interface fast Ethernet 0/0, IP address 10.0.0.1. The fonts are less, so I will change the font size. Just wait for 1 second. Appearance font type is 10. I'm going it for 14. Apply, and also I will change it for default setting. Apply. Okay, IP address 10.0.0.1, 255, 255, 255, 252. No shutdown. On second router, we have 2 interface. First of all, F is 0/1, which is 10.0.0.2. And after that F0/0, in which I have to use 20.0.0.1. Okay, 20.0.0.1, after that no shut, exit. And on last router, on R3, we have interface fast Ethernet 0/0 with 20.0.0.2. And loopback address I can take with interface L1, 3331, 255, 255, 255, 255. So I have to configure static routing and I have to work for both network route as well as host route. So now what is a network route in static routing? So network route is like on R1 I have direct network 10.0.0.0 only. So 20.0.0.30 is the network, indirect network for 10. So that's why when I will configure route for 20, it will become network route, and now 3331 I'm using it /32, so it is like a host root for R1. Okay, so let's move on to the practical. We will do the practical. So on R1, the command I have to use for 20 network IP root 20.0.0.0, 245, 245, 245, 252, and the next hop is 10.0.0.2. This is your network root, IP root for 3.3.3.1, and the subnet mask is 255, 255. So this is your host root from R1. But it will not ping. Until then we have to configure R2. So for R2 IP root, because 10 and 20 are the direct network, so only 3331 20.0.0.2. So we have to configure only one root here. And on R3 I have to configure only one root, that is indirect from my side, that is 10. So this is also known as network root, and it is 20.0.0.1. So after configuring network and host root, you can check router 1's routing table, show IP root. So you can check this is your network root and this is your host root. So if you ping with 20.0.0.1, first packet will fail due to fast Ethernet port and ARP entry. And after that you can ping with 3331, in which also first packet is failed and it is successful right now. So this is the description for network and host root. Thank you. Hello friends, in this video we will discuss about static routing, but the topic is little bit different from static routing because we are going to discuss about floating static route here, like how our route will be float. So in floating static route practical, we have to like play a game with the help of administrative distance value that we know by default it is 1 for static routing. So in this design you can see that already R1 is connected to R2 with 10 network, R2 is connected to 20 network, R3 network with 20, and after that we have a loop back 3331. So here what I am going to do, like for example R1 to R2 I am going to use one more link here. F0 by 1 is connected to, okay, so I think I have to use here serial interface. So first of all I have to put the right command here and off the router, then I can configure. Okay, if you don't want to use serial port, then you can also use here fast Ethernet port, but okay, it will provide us something different, so I'm going to use here. After write, all the configuration will be saved and we can add serial port here. So here you can see we have now one more port is here, serial port. So fast Ethernet 0 by 0 and 0 by 1 is the first link that we have created 10.0.0.0/30, and the serial link that we are going to create new, that's IP should be we can take any 50.0.0.0/30. okay, so I will on the both router. So already I have configured 10.0.0.0, 20.0.0.0 and 3331. So new cable serial 1/0 has to be configured. So we can check on router number 1. First I will use the command show IP interface brief. So 10.0.0.1 is already assigned, so interface serial 1/0 is assigned with 50.0.0.1. So no shut, okay, and on router number 2 interface serial 1Y0, IP address 50002. So now we have two links from, like if we want to transfer our data from R1 to R3. So I have two links, but I want to use concept here like floating static route. Now floating static route means like if my one link down, then router automatically change your path from one network to another network. Okay, so what I am going to use here, I am going to use here the concept of AD. Okay, so for floating static route I have to choose the path. Okay, so I am taking an example of, okay, with written topic I can understand you. For example, R1 has now 10 and 50 connected network. So its indirect network like static route should be for 20 and static route should be for 331. Okay, so now I have two via, like via number 10002, via number 50002, and via number 10002 for this also 50002. Now your company wants that if you are going to ping with 20, then your primary route should be 10002, but if you are pinging with 331, then your primary route should be 50002. So what you will do, you will configure 20 with this route and 333 with 50 routes. But for example, my one route goes down. For example, 50 will down, then you are not able to ping with 3. If 10 will down, then you are not able to ping with 20. So you have to install both the route in this, okay, but you have to install it with the changing AD value. Like for 20 you have to install both the route, but when your via is 10002, then your AD is 1. When your via is 50002, you can change your AD to 10. Okay, and for 3331, via 50002 AD is 1, and via 10002 your AD should be 10. So what will happen? By default they will show you with the lowest ID route. So click on router number 1. Okay, I will erase this. So I am going to configure IP route 20.0.0.0, 255, 255, 255, 252 via 10.0.0.2, enter. So I have not changed the ID value. But when I am going to configure it with 50.0.0.2, then question mark, you can give the distance here. So the distance is 10. And similarly, IP route 3.3.3.1, 255, 255, 255, 255 via is 10.0.0.2, and the AD value is 10, and there is no AD value for 50.0.0.2. Do show history. So these are the commands that we have used here. Okay, now move on to router number 2, because on router number 2 I have to use the command IP route 3.3.3.1, 255 and 20.0.0.2 is your next hop. And for last router number 3, we have two indirect route. One is IP route for 10. Sorry, I put the space. And 20.0.0.1 is the via. And for 50, the via is same. Okay. So first, for testing the floating static route, first I will ping to 3331. First I will check it is pinging or not. Yes, it is pinging. So secondly, I am going to check ping with 20.0.0.1. So it is also pinging. Now check show IP route. So in show IP route, you can see for 20 network via 10.0.0.2 is there because AD value is 1. For 3331 via 50002 is there because AD value is 1. Now for example, my one route goes down like this. My fast Ethernet goes down. So when you are going to ping with 20001, it is pinging. When you are pinging with 331, it is pinging. Why it is pinging? Because the route is floated. Now 20000 is with via 50002 because we have configured this route before, but the AD value is 10. So the concept of floating the route is known as floating static route. Thank you so much. Hello everyone. Our today's topic is about the important protocol of routing, which name is OSPF, Open Shortest Path First. So today we are going to configure single area OSPF network configuration. So let's move on to Cisco Packet Tracer. So in Cisco Packet Tracer, I'm going to take two routers. Okay, and after that I'm using two switch here and two PC in each LAN. So I'm using auto cable, that is using straight cable here. Okay, and I'm using cross cable here because I don't have to connect another router with this. So on first network I'm using 10001, 255, 255, 255, 248, and the gateway is 10003. So the network is 10000/29. So second network is 20001. And 20002 I have to give here. I'm using 255, 255, 248 subnet mask because I need 3 PC in my network. Okay, so this is my 10000/29 and this is my 20000/29. This is 30000/29/30 we can choose here because we need only 2 IP here, so that's why we need /30. So move on to router number 1 and let's start with configuration of IP addressing. Interface fast Ethernet 0/0. The IP configuration video we have discussed previously, so you can see our first video of IP addressing so that it is easy for you to understand the configuration. 248, no shutdown, and interface FA0/1 IP address 30001, 255, 255, 255, 252, no shutdown, and after that exit. If you want to save this, then you can use do write command here. On router number 2, config interface FA0/0, IP address 20003, 255, 255, 248, no shutdown, and F0/1 30002. So no shutdown I have used first, so not an issue. 30002, 255, 255, 255, 252. So let's start with OSPF configuration of single area. So as we have discussed that OSPF is very important routing protocol. Okay, so OSPF works on area. So now I'm going to start with area 0 configuration. Router. So first I have to check do show IP route because OSPF is dynamic routing protocol. It works on direct network ID. So router OSPF process ID, network 10.0.0.0.0.0.0.7, area 0, network 30.0.0.0.0.0.0.3, area 0, and exit. Okay, on second number router, do show IP route, router OSPF, and you can choose your process ID different or same in OSPF, so it's up to you. So I'm using same because I don't feel like it is important. 0007, area 0, network 30.0.0.0.0.0.3, area 0. Now after some time, after sending hello from one router to another router, it will send hello and adjacency will be up. So this is called neighbor adjacency and single area OSPF configuration. Okay, and after that you can check show IP route. So when you will check show IP route, you can check the network coming with O code. O source code means OSPF. Okay, and the AD value of OSPF is 110. And for checking neighbor adjacency, show IP OSPF neighbor. So in this you can check neighbor ID 30.0.0.1 and priority value 1, state is full, and DR connections. Okay, so if you are going to ping with each other, ping 20.0.0.1, same as first packet will be failed, and after that another packet will be successful. So this is all about our network OSPF. Now if you want to check here the concept of database, then you can check show IP OSPF database. These are called link state advertisement. So in my practical, it is single area OSPF, so that's I'm getting only LSA type 1 and LSA type 2, like all are my own network, and the network router LSA is the link state advertisement from my directly connect network and within my area, and network LSA coming from, because I am using fast Ethernet cable and DR and BDR is made, so that's why there are two LSA is used. If we will use multi-area concept, then definitely LSA type 3 will be there. So it's all about single area OSPF. Thank you. Hello everyone. In our last video, we have discussed about single area OSPF configuration, and in that we have discussed about show IP route, that my networks are connected with each other with the help of OSPF configuration. Now the next point is, what are OSPF network types? Like we have point-to-point network type and we have broadcast network type. Okay, so let me clear you one thing. If you are using fast Ethernet cable, like if your MAC address is made, ARP table is made in your router, then this network is known as broadcast network. If I will take another router here, I will save this configuration. I am using here serial cable, and here also I am using serial cable. Like I am going to connect one another network with this interface. Like already I have taken 10, 20, 30. So I am going to use here 40.0.0.0/30, and if you want to use another switch network, then it's up to you. Otherwise you can take directly PC here and we can connect it with cross cable. Okay, so this is my 50.0.0.1. So I need only 2 IP address, so I'm going to use here /30. Interface FA 0/0, IP address 50.0.0.2. no shutdown. Okay, so I have already configured on this router OSPF, so I have to configure here. So first of all, my serial network I have to configure. IP address 40.002.245.245.252, no shut. As you know about like how to configure your routing, then you can directly configure your routing on this interface, but first I have to give IP address on the serial interface on second router 40.001 245, and you can check no shut. So router OSPF1 network 40.000.0.003 area 0. I missed something. I put 0. Okay, sorry, my mistake. Dot is extra there. Do show IP route router OSPF1 network 40.000.0.003 area 0 and 50.000 area 3. So fast forward time. Now already here OSPF is done. OSPF is done here also and here also. Now you can check show IP route. So after checking show IP route, you can check OSPF network here. OSPF network is here. All the direct network are connected with the code of C. Sorry. And indirect networks are connected with O. And you can check also 110/2 here, 110/65, 110/66. So this is the metric value of OSPF, which is known as cost. So if I am using fast Ethernet cable, then my cost is, okay, I will show you the concept. Then formula is cost. Fast Ethernet cost is 100/100 is equal to 1. Now what is the meaning of this? Because the formula is 100 divided by link bandwidth. So link bandwidth is 100. Cost is 1. So if I am going from here to here and there, for 20 network 1 plus 1 is equal to 2. But serial interface cost is 1.54 Mbps, so the cost is 64. So 64 plus 1 is equal to 65 up to this network 40, and for 50 network it is 66. You can check here. Okay, now move on to the concept of broadcast and point to point. Okay, I'm going to check show interface FA0/1. This is fast Ethernet. So if you will check F0/1 here, you will see the hardware is this, address is this, and also you can check here reliability. You can check here interface address and MTU, bandwidth and delay. Now this is the interface information, but if you are looking for specific OSPF interface information, then show IP OSPF interface F0/1. Show IP OSPF interface fast Ethernet 0/1. Then you can check with this. Then you can check F0/1 is up and network type broadcast. I already told you its cost is 1. Process ID is 1. Router ID is 1. So now what is the concept of router ID, that we will discuss in next video. Okay, and network type broadcast means that I have hello timer 10 second, dead timer 40 second. So difference between broadcast and point to point is, in broadcast network when I will check neighborship, then DR and BDR will be there. But if I will check point to point network like show IP OSPF interface serial 0/0/0. Then you will check its network type is point to point. But if I will check show IP OSPF neighbor here, then there will be no DR and BDR will be there. Oh, sorry, I put any wrong command here. Yes, there is no DR and BDR. So this is all about the difference between if you are using serial cable and fast Ethernet cable. So it is equal to point and broadcast network. Thank you. Hello everyone. In our last video we have configured OSPF as well as we have discussed about broadcast network and point-to-point network. But the one concept was missing in the network in our last video, that's name is router ID. So first of all we need to know about what is a router ID. Router ID is the identification ID of any router in OSPF, and it is the unique ID in OSPF, but in EIGRP it can be same. Now how to choose a router ID, that we have to discuss. Okay, so if I have to discuss about router ID, then I have 3 steps. I can manually configure router ID. Manually router ID I can configure on my router. The second step is highest loopback IP address. So I'm not using any loopback IP address here, but in this video we will going to use this. So if I will not choose manual router ID or I will not choose loopback IP address, then by default highest IP address of any non-loopback interface will become your router ID. Like for example, this router is connected with 2 parts. One is with router and one is with switch. Okay, so I have not used in my last videos loopback or manually I have not configured router ID. So this network is 10.0.0/29 and this network is 30.0.0/30. So the interface IP is 10.0.0.3 is F0/0 and 30.0.0.1 is F0/1. So if I'm not choosing any loopback interface, then what is the highest IP address of this router? So 30.0.0.1 is your highest IP address of non-loopback interface. So that's why it will become its router ID. So you can check it with show IP OSPF interface. Then you can check the router ID is 30.0.0.1. And if you will go to next router, then you have to check the highest IP. Then 20 is this, 30.0.0.2 is this, and 40.0.0.1 is this. So if you will check here show IP root and show IP OSPF interface, then you can check router ID is 30.0.0.2 here, while my 40.0.0.1 is my highest IP address, because I have not used one command here, clear IP OSPF process, because in our last video when we have discussed, this is previous design and I have extended this design. So clear IP OSPF process, I have used res, yes. So after using clear IP OSPF process, when you will check show IP OSPF interface, then you will check that your router ID is now 40.0.0.1 because this is the highest IP address of non-loopback interface. And on this router, one is 40 network, one is 50. So definitely 50 will be your router ID. 50.0.0.2 is your router ID. Now the task is, for example, you want to manually select router ID. So what you have to do? You have to go for router OSPF1 router ID. For example, you want to give like this. Okay, so you have to use command clear IP OSPF process. Yes. So your router ID is this. I have used this command, and now fast forward time. So when you will check show IP OSPF interfaces now your router ID is 1.1. What I have done, do show history. I have done command router OSPF 1 router ID, and after that do clear IP OSPF process. So after clear IP OSPF process, my router ID is this. Same as if I am going to configure here any loopback interface loopback 1 IP address 5.5.5.5. For example, I am using this. Okay, first I have to put this loopback interface in my 0003 in my routing. So this is configured. Okay, so if now I use clear IP OSPF process here, yes, then you will check router will select loopback IP address as a router ID. Show IP OSPF interface. So 555 is your router ID. So we have three processes. Either you can manually set your router ID, or it will choose with highest loopback IP address, or it will choose with highest non-loopback IP address. Thank you so much. Hello everyone. Our today's topic is about first hop redundancy protocol. Okay, in our last video we have discussed about routing, we have discussed about router ID, and we have discussed about so many things. But today's topic is about first hop redundancy protocol, FHRP. So in this video we have to describe the purpose of first hop redundancy. So what is the meaning of first hop redundancy protocol? So the meaning of this is, like for example, we have one switched network, and we all know that all the switches, all the PCs are directly connected with switch, and they all have one default gateway which is assigned to router's fast Ethernet port or Giga Ethernet port. Okay, and for example, this router is connected with another router, and this router is connected with internet service provider or cloud part. Okay, so these PCs can ping with ISP with the help of this path. But for example, suppose this path goes down. For example, there is problem in switch port or router port, or in their problem in cable. So these PCs are not able to connect with ISP because we have only one network here. Okay, so the solution of this, we can put another router here as a gateway F0/1. Okay, and we can connect with this also. But the problem is, on our PC I can put only one default gateway. So this gateway can be this, or it can be this. For example, two PCs have gateway this, two PCs have gateway this. For example, this router goes down, then these two PCs are not able to connect with ISP through this router automatically. So in the concept of first hop redundancy protocol, if we have these types of design, like this one, and this is connected with ISP, then what we can do, we can put here virtual IP here, and we will provide virtual IP as a gateway to the LAN devices, and we will put that virtual IP on physical interface of their gateway. Like we will put some commands and we will provide virtual IP to this. Now the benefit of first hop redundancy protocol is that, for example, if one router goes down, then these switch or this network automatically switch all the processes from another router. And the example of FHRP is, hot standby routing protocol, virtual router redundancy protocol, gateway load balancing protocol. With the help of these high availability or first hop redundancy protocols, we can transfer our all the database if my one links goes down to another interface. So it will save us time. So this is all about first hop redundancy protocol. Thank you so much. Hello everyone. Today we are going to discuss about NAT. NAT stands for Network Address Translation. It is used to hide internal IP address space from outsider. So we have to configure static NAT in our this practical. So I'm going to take 3 routers here with 3 switches for making the design. So I'm going to connect these devices with each other. So this is the basic topology. Actually, I have to configure inside NAT. So for inside NAT, I have to first need to know about what is NAT. Network Address Translation. It is used to hide internal IP address space for outsider. It is used to save IPv4 address with network address translation. It has 3 types. First type is static NAT, and second type is dynamic NAT, third type is overload NAT. And overload NAT is also known as PAT, port address translation. So let's discuss about static NAT first. So I have to make design first. 10.0.0.1 255 to 48. So first I have to configure IPv4 address here. 10.0.0.2 20.0.0.1 20.0.0.2. So our PCs are going to configure. So I'm going to take this network as a 40.0.0.0/30 and 50.0.0.0/30. So let's move on to the IP addressing part. So first I'm going for IP addressing here. So I'm going to start it from scratch, like first IP addressing, after that I will do routing, and then I will do our static NAT concept. So FA0/0 I'm going to configure with 10.0.0.3. So this part you have already covered, so I'm going to do it little bit fast, because IP addressing part you have done so many times in routing, in inter-VLAN routing, in another routing. We have done these all the parts. On second number router, I have to configure 3 interface. First I have to configure FA0/0, that is 20.0.0.3 255 to 48. Sorry, 248, because I have 3 IP address. If I had 2 IP address, then definitely I will use 252 40.0.0.2 and serial 001 is 50.0.0.1. We can also configure it 50.0.0.2. So that on next interface I will configure it 50.0.0.1, like on this router. $50.0.0.2 I have already configured, so I am here configuring 50.0.0.1. And fast Ethernet IP, that is the gateway for LAN number 3. that is also configured. So now IPs are already configured. Now you can use static routing, dynamic routing, OSPF routing. That routing you like the most, you can use that routing. Okay, so we have not used RIP routing in this current version of CCNA because RIP is already removed. But just for the practical, I can also use RIP information here. Version 2 not a summary, sorry, version 2 not a summary. So it's up to you, you want to configure EIGRP, OSPF, so you can configure that also, but I have configured this routing protocol just for the practical of NAT. And on last router I have two direct network, router RIP, network 30000, network 50000. So version 2 not a summary. So for save the data I'm using write command here. Do write. Okay. Now definitely they are pinging with each other. First packet is failed due to ARP entry. Okay. So now I have to configure static NAT here for inside network for 10.0.0.1 and 10.0.0.2. So like if 20.0.0.1 is going to ping with like I have to ping with from command prompt ping ping to 10.0.0.1, then it is pinging via 10.0.0.1. If I'm going to ping it with 2, then it is going to ping with 2 easily. But if you are applying NAT here, like inside NAT here, so when outsiders are going to ping with you, it will not let you know the real IP address of this. So it will save its real identity, and by faking its identity it will reply. So first of all I have to configure NAT interface FA0/0 IP NAT inside, exit interface serial 0/0/0 IP NAT outside, and I have to use command IP NAT inside source static 10.0.0.1. Now 10.0.0.1 is your inside local IP. You can check inside local IP addresses 10.0.0.1. Now I have to show here inside global IP, like which IP address you want to show to your outsiders. So I have used 200.200.200.1. Okay, and similarly for 10.0.0.2 I am showing 200.200.200.10. Do show history. So I have used 2 inside NAT command. When I will ping from outsider now, for 10.0.0.1 reply from 200.200.200.1, and for 10.0.0.2 it is replying via 200.200.200.10. So my real inside IP address is changed into the given IP address. So this is the concept of static NAT. Thank you. Hello everyone. In our last video we have discussed about NAT, and we have configured static NAT on this topology. And static NAT is one-to-one translation. But today we have to discuss about PAT, port address translation, which is also known as many-to-one communication, and we can call it as overload NAT. Like within overload NAT you can like provide only one global IP address to all the IP address that are given in LAN. So I'm just extending my LAN network. Like I have 4 IP address, 4 pieces. Already I have configured 10.0.0.1 and 2 to my first 2 PC, gateway is 3. So my 4th PC is 4th IP is 10.0.0.4 and 10.0.0.3 is the gateway. 10.0.0.5, 10.0.0.3 is the gateway. So already I have done routing here. So first packet is failed and the next packet is successful. Yes, so they are successful now. Now I have to configure overload NAT here with the command of pool. Okay, so first of all I have to use FA0/0 IP NAT inside exit and the packet outsider. I have to show IP NAT outside. This one. So this is my inside network. So I have to configure inside NAT and this is outside. So first of all I have to create pool here, IP NAT pool and pool name. For example, I have given pool name CCNA. Then I have to provide start IP address, that is from global range. Okay. And end IP address. So if I am using overload NAT, then my start and end IP address remains the same. And net mask, you can take net mask according to your need. I have used an 252. Now this is the pool for the global IP address, inside global IP address. Now I have to permit my network 10.0.0.0 with 0.0.0.7 wildcard mask. This access list is used for like only 10 network will change. For example, I have connected another network with this router also. So that's why only 10 network will be permitted to change into 200. Okay. So the command is IP NAT inside source list. List 1 pool CCNA and at last I have to use command overload. With the help of overload command, what you will check if you are going to ping with 10.0.0.1, 2, 3, 4, but the reply is taken from only this IP address. So let's check. PING 10.0.0.1. So you can check 200.0.0.1. 200.0.0.1 remains same. So with the help of overload NAT, you can save your IP address space, because in NAT we need public IP address. So within overload NAT, I have only one public address for all the IP address that are in the LAN. So this is all about overload NAT, which is also known as PAT. Thank you so much. Hello friends, our today's topic is about network time protocol. And basically it is known as NTP, and we have to discuss about what is the working of NTP. So basically in NTP we have to work on router, switch, server. It is basically used to set up the updated time for router. We have two options. Either we can set clock set command, or we can set up NTP server on our router. So with the help of clock set command, you can set updated time on your router, and with the help of NTP server, it is automatically connected with this. So let's start with the practical, because it is totally practical topic. So first of all, I have to take one router, one switch, PC if you want to connect, and one server. So on this server I have to configure NTP. So this is called network time protocol. So I am giving IP address to this F0/0, IP address 192.168.1.1. So I'm using C class IP, and this is your 192.168.1.2, 1.1, because gateway IP address is 1.1, and this server's IP is 192.168.1.3, and the gateway is 192.168.1.1. Okay, now first of all check the basic configuration that every PC or server is connected to router. Yes, so this is the basic configuration. Now if you will check on router, show clock, then you are checking there are 250 or 225 UTC Monday 1, so 193 is the time. So you have two options. I have already told you, you can use this command like with the help of clock set. So with clock set you can use this as a in CMD or in like CLI mode. Either you can use one command here, NTP server 192.168.1.3. we have set the NTP server. Now click on server, service, NTP. You have to enable this. Now my system time is 10:37 this, and today is 1st June I have set. So NTP server is on. Authentication, we don't need authentication. Off and on, 1. Okay, now show clock. You can check with the help of NTP server, it is automatically updated the time. So now 1st June 2021 here, so it is updated by this. Now for example, we don't have NTP server, and for example router configuration is reset, then what is the alternative for this? So the alternative for this is interface FA0/0 IP address 192.168.1.1 255.255.255.0. So oh sorry, my mistake. FA0/0, this one, no shut. So I have to use this command. Now you will check show clock. Clock set, manually I can set the time. So this is R 10:38 seconds, question mark, 1st June 2021. So with the help of this we can set. But NTP is the updated method, so we have to use NTP server. Thank you so much. Hello everyone. Our today's topic is about DHCP. So DHCP is basically known for providing IP address automatically to LAN devices. Like for example, you don't want to configure each and every PC manually, then you can use DHCP. DHCP full form is Dynamic Host Configuration Protocol. So if you want to configure DHCP, then you need to create one pool of IP actually, because we need a range of IP address. After that we have to define default gateway address, and after that we have to define network address. And also you can also provide DNS IP automatically with the help of DHCP. So let's have a practical of DHCP. Okay, so first of all, I have 5 PC in my LAN network. So for 5 PC, I'm going to choose 192.168.1.0 network, but /29 because valid 6 IPs we can use in this. So first of all, you have to configure gateway IP 192.168.1.1 248. No shutdown, exit. Okay, so if we have to configure IP address automatically, then you have to choose DHCP options. But before choosing DHCP option, you need to learn. For example, if we have not configured DHCP yet and we are clicking on DHCP, then what will happen? Then one address which name is APIPA is being used. APIPA means automatic private IP addressing. Its range is reserved 169.254.0.0.0. Okay, so before clicking on DHCP, first click on static and configure your router. IP DHCP pool name. With network command, you have to mention which subnet mask you are using. What is your default router? That's it. But for example, if you have DNS also, for example 1.1.1.1, then you can also choose with this command. So now our DHCP configuration is done. Now if I will click on DHCP, it will take IP from the pool and automatically assign IP address, subnet mask, default gateway and DNS server. You just have to click on DHCP and every configuration will be done here. Thank you so much. Hello everyone. Let's start with the topic of DNS and SNMP. So in our this topic we have to discuss about what is DNS and what is SNMP. Okay, so in our last video we have discussed about what is DHCP. Okay, so in this video we are going to discuss about DNS, domain name server. Okay, let's start with DNS. DNS is domain name server which is used to resolve IP address to domain name, okay, and domain name to IP. Like if we have DNS nowadays in our network, then we are easily going to access about our website with the help of given name. For example, each and every web server has its own IP address. Like for example, facebook.com, I am taking example of Facebook. For example, Facebook IP is 157.169.1.2. So Facebook is the domain name and IP address is assigned to the server of Facebook. Okay, so actual pinging process is going to IP, but DNS is used to resolve the domain name from this IP address. Okay, so basically DNS is used to resolve IP to name and name to IP, and its port number is 53. On the other hand, we have one more topic which name is SNMP. SNMP is Simple Network Management Protocol. Like you can say SNMP is a framework used for managing devices on the internet. Okay, it is used for configuration also, basic network management configuration. Okay, but basically it provides a set of operations. The main purpose of this set of operations for monitoring and managing the internet. And many people's questions about SNMP, that SNMP is used nowadays or not used. So little bit sadly it is used, but it is still in common uses. You can say that it is in common uses. Later version of protocol have addressed numerous issues in SNMP v1. In SNMP v1 they followed some issues, but those have almost entirely been directed at fixing the security models. Okay, so SNMP is Simple Network Management Protocol and DNS is Domain Name Server. Thank you so much. Hello everyone. In our last video we have discussed about NAT, overload NAT and static NAT. In our this video we have to discuss about Syslog and SNMP. Okay, so SNMP you have already know about that it is Simple Network Management Protocol. And what is Syslog? Syslog server, like Syslog, first of all, Syslog stands for System Logging Protocol. As you have seen, there is a Syslog server, and Syslog server is connected with the workstations, applications, and other servers. There are Syslog message server, device, workstations. So System Logging Protocol is a standard protocol which is used to like send system logs or event messages to specific server. For example, these are specific servers. So Syslog is used to send these logs from like to event message to specific server. It is known as Syslog server, which server it sends this, and it is primarily used to collect various device logs from several different machines. Like it can take information from workstations, applications, and so many machines it can use, and it takes information from these machines in a central location for monitoring and review. So this is known as System Logging Protocol. Now, besides this, we have SNMP also. Now, what is SNMP actually? Okay, so SNMP is your Simple Network Management Protocol. Okay, why SNMP use? As you can see in this diagram, you can see there is a manager and trap receivers. They are getting and set request and set response. They are taking from master agent. With master agent, you are seeing agent 1, 2, 3, 4, 5 are connected, and with manager, which are sending get and set request, agent 6 is there. So how SNMP work here? SNMP is simple network management protocol, like they are managing each other. SNMP is also a framework used for managing device on the internet. Like on the internet, you can use your device from one location to another locations. And SNMP also provides a set of operations for monitoring and managing the internet. So this is all about SNMP and Syslog. Thank you so much. Hello friends. Today we are going to discuss about DHCP via server and DHCP relay agent. Because in last practical of DHCP we have discussed when we have created the pool of IP address and default gateway and network command. But today we are going to make this server as a DHCP server, and also we will provide IP address to this PC with the help of DHCP relay agent. So first of all, I'm going to configure this network as I am taking interface FA0 by 0, IP address 192.168.1.1, no shutdown, and for F0 by 1, 192.168 dot, sorry, 192.168.2.1, 255.255.255.0. So both the links are up. Now I want to make this server as DHCP. So what I have to do? So I have to give manual IP address to this DHCP server first, 192.168.1.2. 192.168.1.1 is the gateway, because this fast Ethernet port IP is 1.1. So first of all, I have to check the pinging here. It is successful. Now I have to create DHCP pool here. So by default we have pool here, and default gateways, and I'm not using DNS, so there is no need of DNS. But if you want to use, then you can use any random IP. It's up to you. And now your start IP address should be from 1.3. Maximum number of user, I have only one, but you can change it to up to you. So it is based on your subnet mask. Now you have to on the pool. When you will click on this and click on DHCP, then they will provide you IP address automatically. Now this PC is already configured with the help of DHCP. Now how to configure IP address on this interface, because if I am using direct DHCP here, then it will give you a PIP address, automatic private IP address, and DHCP will be failed because there is no server in this network. So in this condition we have to use DHCP relay agent. For DHCP relay agent I have to go on the router, and on interface FA0/1 I have to use command IP helper address, and I have to give destination address here. So what is my DHCP address? 192.168.1.2. This command I have used, but only with this command the process will not be successful. I have to make another pool, server pool 2, and I have to give default gateway 2.1 as well as 2.3 and add. So I have server pool 2 now. Now it will take IP from this server and provide to this. You will go for fast forward and you can check now same same DHCP server that is on different network provide IP address to this PC. But it is providing IP address. I think it is choosing the pool name. It choose the pool different, so I have to change the pool here. Yes, no, it's okay. Pool name is, this is one network. Actually I have mistakenly write something here like this. Okay, so this is right, and 192.168.2.3 is this PC's IP, 192.168.1.2 this IP. Actually I have written IP address 1.0 here and 1.2.0 here. So that's why this was a mistake, but there is no mistake in this. So this is the concept of DHCP server and DHCP relay agent. Thank you so much. Hello everyone. Today we are going to discuss about quality of services. Basically quality of services, and we have to explain the forwarding per hop behavior for QoS, such as classification and marking, congestion avoidance, congestion management, what is policing and dropping the procedures, so many things. So we have to discuss in this. But first of all, we need to know about like what is QoS. So what is QoS actually? QoS refers for quality of service, like refers to tool. First of all, we need to understand that it is a tool that network device can be used to manage several related characteristics of what happened to packet while it flow through network. Like specifically these tools manage the bandwidth made available to that type of packets, and after that it is the delay of the packet experiences, like how much delay in this, jitter, and also with the same flow of the percentage of packet loss of each class. So we have to discuss like how many things are used in this, how QoS tool defines everything, and how they are taking actions. Okay, so basically if we talk about QoS, we can say router typically used in this, and it is used for the WAN edge. All the routers are connected with each others, and they are providing with LAN and WAN interfaces, and the LAN interfaces typically runs more faster speeds as compared to WAN. WANs are for slow speeds, and while the we can say the router, in routers we have little bit slow speed, because for router we have so much traffic from one interface to another interface. Okay, so we have so many things like we have to go for like project queuing, packets are in queuing, policing, dropping the packet, scheduling the packets. So these are the things that are used in this. Like there are some, like you can say, things that are used for checking the congestions. Like there is a bandwidth factor is there is a delay factor is there, jitter factor is there, load loss factor is also there. Bandwidth is like a speed of the link, like how much bit per second data you can send from one interface to another interface. Delay means round trip delay or one trip delay. Like one trip delay between I'm sending the packet from one interface to another interface, and the same packets arriving at the destination host in what time, how much time it will take to reach. Okay, that is also, and how much delay it will take. So this is also a factor. And also one more factor is here, which is known as jitter. Bandwidth and delay we know easily, but what is jitter? Jitter refers to the variation in one-way delay. One-way delay between packets sent by the same application. Okay, so this is known as jitter. Besides this, we have one like how to check the loss in the packets. Like for example, you are sending messages one information to one port to another port. Then loss refers to the number of lost messages. Like I am sending messages to my friend and I am sending 500 messages, but he receives 400 messages. So loss refers my number of lost packets. So these are the factors that are used in QoS per hop behavior for classification, marking, congestions and shapings. Thank you so much. Hello friends. In this video, we are going to discuss about Telnet and SSH. Okay, so first off, Telnet and SSH both are used for remote connectivity. So in this, if you want to connect your router, if you want to configure your router from remote location, then you can use Telnet and SSH. So okay, I'm going to configure that on Cisco Packet Tracer. So in this design, I'm taking one router here and one router here. One I will use to configure Telnet and one I'm going to use configure for SSH. So in both I'm using 2233 PCs. Okay. So first of all, we have to configure Telnet. So for Telnet, what we have to do, first our IP address should be there. So I'm going to configure one IP address here, enable config interface FA0/0, IP address 10.0.0.1, 255, 255, 248. So 10.0.0.1 is the gateway for these two PCs. 10.0.0.2, 255, 255, 255, 248, and 10.0.0.1 is the gateway. 10.0.0.3, oh sorry, 140. Okay, so now they are pinging with each other. Okay, now your task is you want to access your router from this PC. Then you have to configure Telnet first on your router. So for configuring Telnet, one important thing should be remember that for Telnet enable password should be set. So I have to set password enable 1, 2, 3 here, and after that I'm going to configure line VTY. Line VTY, by default it is 0 to 4. I'm giving password 1, 2, 3, 4 to this, and it is by default to login. So it's okay. I'm using command do show run. Your enable password is 1, 2, 3, and your Telnet password is 1, 2, 3, 4. So now let's move on to this PC. On this PC, I'm going in command prompt. First I'm going to ping 10.0.0.1. If it is successfully replying, then I can do Telnet now. Telnet. So first of all, if you are accessing Telnet, you have to put password 1234, enter. Now you can check router is there. You have to put enable command and put enable password 123. Now you can access your router with the help of Telnet. But in Telnet there are some security issues. So if we are facing some security issues in our network, so we don't find it like very secure network. So instead of Telnet, nowadays people's using SSH. SSH is secure shell. Telnet port number is 23 and SSH port is 22. So same as I'm using this, I'm going to use FA0 by 0 20001 245 245 248. So in this I'm using different network. This is 20002 245 245 245 245 245 248 20001, and also we have to go with 20003 245 245 245 248 20001. Okay, so now we have to check they are pinging or not. Okay, so they are also successfully pinging. Okay, so in this, now move on to router. So for SSH configuration we have to use command IP domain. Wait, we don't need to use this. IP domain name, any name that you like. I'm putting IP domain name admin, and after that I have to use crypto key generate RSA. So now I have to define host name other than router, because if every router has a default name router, so I have to change router. So I'm changing its name into XYZ. Okay, now I'm using IP domain name admin, crypto key generate XYZ. Now I have to put, okay, so in this you have to give the size of the key. So I'm giving bits 1024 bits here. So it is my 1024 bit RSA key is generated. So enable password I have to give here. So I'm giving enable password 1234. So enable password is 1234, and after that I have to give username and password. So my username is same as admin, password is same as admin. Okay, so after configuring IP password, you have to admin password, you have to put SSH command IP SSH version 2, and now I have to use command line VTY. So by default it is 0 to 4, but you can give also maximum 0 to 15. Okay, so transport input I have to give here SSH, and login I am using just local because local network is there. So in do show history you can check all the commands that I have given. Now I have to move on to my PC, ping 20001. Okay, so it is pinging. Okay, so within this I have to go for, now I have to check. So I have to check here, it is pinging 20001. So I have to check that SSH is working or not, because in this I was using telnet command. As you remember, in our first practical I have used telnet command, and the password should be there. Okay, the router was open, but now my router name is XYZ, and if I have to check, then SSH connection command is SSH. L stands for login local. and I have to put my username and IP address. So I have used my username here, admin, enter. So password I have also used admin. Okay, so my router is open, and now my enable password is 1234. Okay, my router is access, so you can put your admin enable password and you can ping your router and you can access your router. So this is the configurations for your SSH, and this is the configuration for your Telnet. Yes, my password was 1234, that's why it was giving bad. Yes, sure run. Okay, so thank you so much. Hello everyone. So today we are going to discuss about FTP and TFTP, file transfer protocol and trivial file transfer protocol. So we have discussed about so many time in FTP and TFTP about. So basically FTP is file transfer protocol which is used to transfer or copies the file from one host to another host, but there may be some problems like different file names, different file directory while sending and receiving files in different hosts or systems. Okay, so FTP in FTP secure channel is not provided to transfer. So as we are discussing about FTP, there is no secure channel provided to transfer the file between the systems, and FTP has ports 20 and 21 for data transfer and one is for connection control, as you are seeing in the video. While TFTP is trivial file transfer protocol, it is used to transfer a file either from client to server or from server to client without the need of FTP features, and the software of TFTP is smaller than FTP. Okay, so this is the benefit, and TFTP work on 69 number, and also it is used by UDP. And extra what we have to discuss about it, FTP support authentication but TFTP don't support authentication. Okay, FTP works on TCP transmission control protocol, and TFTP is user datagram. Like it is connection oriented, it is not connection oriented. It is used robust control commands, and yes, this is used for simple control commands. Also in FTP it use TCP connection, like three-way handshake process is used by FTP, but there is no three-way handshake process used by TFTP. So this is the important difference between this. And after that, mostly used by remote user to upload and downloading files, and TFTP is used to transfer configuration to and from network device. Like for example, if you want to transfer your file from one network to another network, you can use FTP. Okay, and in FTP it requires more memories and programming efforts. Okay, and if you are like configuring your router image or you are configuring your router, then you can use simply TFTP because it require less memory and programming efforts. So this is used for TFTP is basically used in our router configuration and update flash, update iOS and another things, while FTP is used to upload the file that are from different locations. So this is all about FTP and TFTP. Thank you. Hello guys, our today's topic is about security concept. As we have discussed previously that why we need security. For example, user want to prevent unauthorized access from outsiders, then they provide security. But besides security, beside the security, we need to understand about some threats, some concepts of securities. So in these security concepts, we have vulnerability. We need to know about what is vulnerability, exploit and payload. Okay, and before this, we need to know about one more thing, threat. Okay, threat is anything that is man-made or act of nature that has potential to cause of harm. It is used in ethical hacking also. Threat is also defined as a potential for violation of security, which exist when there is circumstances, capability, action or event that could breach the security and cause harm. Okay, and vulnerability is existing of weakness like design or implementation error that can lead to an unexpected event compromising the security of system. So for example, if in our system, my system is vulnerable, it means anybody can attack on my system and anybody can hack my data. After that, what is exploit? Exploit is like a breach. Like in whole IT system security through vulnerability, it is a security breach. So when the security breach is there, when we give the term name exploit. Okay, and payload is there. Payload is like your script. Like for example, I am working as a hacker, then I will make one script and that script named is payload. Payload, it is the part of exploit code that can perform any malicious action such as destroying, creating backdoor and hijacking computer. For example, any person who is hacking your system, after hack the system, he removed the footprints and he installed backdoor there. Then on next time he don't need to come here for like on the front face. He can install the backdoor and he can hack your data. Okay, so what type of things, that what type of security programs or element that we need to know in this, like for security purpose, what type of program we can done, so that are known as security program element. Like what we can do in this, in security program, what we can do, we can go for user awareness. So user awareness is like, for example, all users should be made aware of the needs of data confidentiality. Okay, like why they need to be made aware of that? They need to be made aware of that because they need to protect the corporate information as well as their own credentials also. Like some people use their personal laptop there, so they have to secure their networks also. They should be made aware of potential threats, schemes to mislead. They need to know about like what is the proper and what are the security holes in nowadays. Okay, they should not keep or transmit that information, any information through smartphone, or they have to store it through the cloud services. Like these are the things that we need to provide as a security program element. And next type, we can provide them training also. Like this is called user training. Okay, user training. Like what we can cover in user training, like all users should need to participate in any type of formal training about security. They have to become familiar with all corporate security policies. They need to know about like how we can provide security to our employee identities, users, business partners and another things. The next thing, we can provide like physical access control. This is the main important thing. Why physical access control is better? Why it should be better? Because if our network is not closed, like anybody can come and go there, then there may be security loops also. Okay, so infrastructure locations such as network closes, data centers, companies, server rooms should remain securely logged. Okay, administrator can control the access, he can come or go there, but other users are not able to come inside the server room, or where we can see the like there is a security, so we don't have to allow that person into our security rooms. So these type of security programs we should have to implement on this. So this is all about the security concept and our security program elements. Thank you so much. Hello everyone. Today we are going to discuss about security passwords. We have to discuss about the password that we can set on our routers. Like in our last practical, when we were configuring Telnet, we have used the enable password. But besides the enable password, we have another local passwords that we can set on Cisco router. So let's start with the practical. Okay, so first of all, I'm using one router, one switch and two PC in my design. So I'm giving IP address first, because if we remember that for Telnet I need IP address on this. F is 0 by 0, IP address 10.0.0.1. So for another password I will set. So I'm just using class full network and I'm giving 10.0.0.2, 10.0.0.1 is the gateway, and 10.0.0.3, 10.0.0.1. Okay, so this is my basic design in which PCs are connected with each other and PCs are also connected to router also. Okay, now when we configure our router, we can say that when after booting directly we have this mode. This mode is known as user mode. So when we start the router after continue with configuration mode, then this is known as user mode. After user mode we have enable mode, and you call it like a privilege mode also. Privilege mode, like you can set privileges in this mode. And after that we have global configuration mode. Okay, so we have these types of modes, global configuration mode. So for example, you want to set password on user mode. Sorry, I put username instead of user mode. So if you want to set password on user mode, then this password named as console password. And okay, and after that if you want to put password on enable mode, then you can put two types of password, enable password and enable secret. After that, if one port of router is also auxiliary port, have you seen the original router when we have configured IP addressing, then you can password set on auxiliary mode, then auxiliary password is there. And after that, if you want to set telnet password, then you have to configure telnet. So we have some type of local password that we can set on our Cisco router. So let's start with console password first. So the command is enable config. You have to put line console 0 password 123 login. So the command is line console 0 password 123 login. So if I will back exit, then it will ask me from the password, like what is the password for user mode, 123. Then it will open. Now you want to set password on enable mode. Okay, so that is known as enable password. So I'm using simple password 1234 here. Now exit and exit. So first password is your console password 123. And now when I type enable here, then it asks for password 1234. So this is your enable password. And enable passwords is less encrypted, like less secure as compared to enable secret. And enable secret has a high priority. For example, you set enable password and enable secret both at one time, 1 2 3 4 5. Now my enable password is 1234 and secret password is 12345. So it will provide the authority to enable secret. Okay, for example, you are typing enable. I'm typing 1234. It's not open. 12345. It is open. So enable secret is more priority wise like this. And now after that I want to show you one thing. When you put show run command, then enable password is visible for the user, but enable secret password is not visible. So that's why it is also secure. And line console 0 password you can write from here. Similarly, we have auxiliary password. The command is totally same. Line auxiliary 0, password 123, exit. Okay, so if you will check show run, you will find this password also. And if you want to set telnet password, then the command is same. Line VTY 0 to 4. 0 to 4. So password is, for example, 098. Exit. And if you want to access your telnet from your PC, then you can put telnet command 10.0.0.3, sorry, 10.0.0.1, 098, enable 1 2 3 4 5. You can open your router. And at last, if you want to encrypt all the passwords here, then you can put this command service password encryption in config service password encryption. With this command, all the password in running modes are encrypted. Now you can check secret password, enable passwords, all the passwords are in encrypted format. Okay, so this is all about the basic password. Thank you. Hello everyone. Today I am going to discuss about security password policies elements. Okay, like we have discussed about security, why we need security, we have discussed about vulnerability, threats, payloads, but now we need to discuss about some security policies elements such as management, complexity, password alternatives, like you can set multi-factor authentication certificate and biometric. Okay, so why we need security, that we have discussed already. Okay, but what are the security password policies that need to be implemented, that we are discussing now? Like for example, a simple password string in the single factor that is must enter to be authenticated. Okay, because the password should be remembered and not written down anywhere. Okay, you might think of your password as something you know. Okay, hopefully nobody else know it too. Otherwise, they could use it to impensate that you are authenticating. So password is a very strong identity in this. Okay, so enterprise must consider about these alternative credentials, like what are the password? The password are complex or not. Like if your passwords are not complex, then anybody can hack your network. Okay, mostly tough password provides you more security. Okay, so this is also a best thing that you have to use your tough passwords. And multi-factor credentials are also used in this. Multi-factor authentication is also used. Multi-factor credentials require user to provide the values or factor that comes from different resources. Okay, like for example, dynamically some people are using their fingerprints, their retinal pattern, voice or face. Okay, some people only knows their password pins and KVAs. Okay, so we have so many things that we need to know about what provides us a security. The another things that provide you security, what you can do, you can use digital certificates. Multiple companies use digital certificates which can serve as an alternative factor because it serves as a trusted form of identification. Okay, so this is also it can be used here. But digital certificate are also time sensitive. Okay, at each is approved for a specific time range. Once a certificate expire, any attempt to authenticate with it will be rejected. Okay, and after that, what you can do, you can use certificate based authentication. It is like a digital certificate which will identify the user or machine. Like if I want to take a grant, or I want to take grant access from my company's PC, then there should be digital certificate for me, for anyone, that provides me the security. Because digital certificates are user friendly and they have access control policies also there, and they have mutual authentications, like company peoples are also used. Okay, so multi-factor authentication is also a good deal. In multi-factor authentication, like for example, I am taking example of two-factor authentication in Facebook. Okay, like for example, I want to open my Facebook, okay, and I'm logging. Somebody see my password and somebody have hint of my password, then he is trying to open Facebook. But if I have implemented multi-factor authentication on this, and then what will happen, and he will going to open, then one OTP comes to my site. This is also authentication. For example, before OTP, they can send me mail from my Gmail also. So these are the things that should be implemented on my passwords, so which can provide us security. Okay, so this is all about password policy. Thank you. Hello everyone. In today's topic, we will discuss about virtual private network, VPN. What is VPN? Site-to-site VPN. What is a tunnel? So we need to know about these things because this is the hot topic of our network security. Also, what we need to know about before VPN, that what is the remote access. So in easy way, what is the remote access? Like I am sitting on another location and I want to access your laptop, and you are 100 kilometers away from me, okay, and I want to access your laptop with the help of public IP address, or I can access your PC with any third party remote control applications. So this is the example of remote access. Remote access means I am working on your PC, even I am not located in your location. So that is known as remote access. Now, what is VPN? First of all, we need to know virtual private network. In virtual private network, what we can say it, like for example, this is your public cloud where you want to get the internet, public cloud. Like you can say this is internet, because in our internal area we use intranet. Now anybody can use this internet, like with the help of this I can access Facebook, Google, or I can talk to my friends that are on different location. So this is my public cloud where are most of the hundreds and thousands of routers are connected with each other. There are so many routing tables are made there, OSPF, EHRP. I don't know what is this. Now what is VPN? For example, here is my company and here is my network, private network. Like for example, there is my private network, and one location of my company is Chandigarh and one location of my company is Delhi. Okay, so I want to access my Chandigarh with the help of Chandigarh network. I want to access my Delhi network, but I don't want to show my routing information to this public network. So this is known as VPN. Like we are working like there is a tunnel in between the network. Okay, for example, we have some like water, like in villages or in like in traditional areas, sometime in old areas, we have water areas. Like this is a dirty water, you can say this is a dirty water. Okay, and now your villager people wants clean water to drink, clean water. I need clean water to drink, and what water supply company is done, they provides a strong tunnel from this location to this location. Like this is a tunnel, and they are also providing this tunnel through this dirty water area also. But if I am sending like drinking water from this pipe to this location, then this dirty water don't impact on this, because this is strong pipe. This is strong pipe, and this water is clean and it can comes to this village or this city. So for example, this is my public network and this is my private tunnel. So when I am sending my data from one private location to another private location through the public network, that concept is known as virtual private network. And we can go for site to site VPN, we can go for secure VPN, we can go for GRE tunnel concept, we can go for IPv4 to v6. So we have so many concepts that will be covered in VPN. So VPN is virtual private network in which we can send our private information to another private information through public network, but public networks don't have our root installed in this. Thank you so much. Hello everyone. Today we are going to discuss about one important concept of security which is known as access control list. So access control list is what? Access control list are the set of commands which are used for denying any information, permit any information, and it want to filter some information from your network to this network to this network. Like access list has two parts, like standard ACL and extended ACL. But most of the time we are using extended ACL because in extended ACL we can use source as well as destination at single time. But within standard ACL I can use only source address. Like in standard ACL what I can use, like for example I want to block my 10 network. This is already made topologies 10, 20, 30 and 40 and 50 network, and already they are pinging with each other. You can check through this simulator command. They are pinging. Like you want to block your 10 network. So in standard access control list you have to implement access list command only on this interface. So 10 network will be blocked with everyone. Like you are not able to block 10 whole network with specific 20001 or 20002 or specifically 50000. But in extended access control list you can completely specifically block 10's whole network with one specific host. You can block it with specific network. You can block specific host of your network with any other network. So this is all about access list. So standard access list used 1 to 99 number and extended access control list used 100 to 199. So let's have one configuration about access list. Now I'm going to give you example of standard access list first. So I'm taking an example like you want to block your 10 network with everyone. Okay, so what I have to do, I have to go for the router. So if I want to block 10, then what I have to use? I have to use command access list 1 deny 10 network, and it's wildcard mask, and also I have to use access list 1 permit any, like 10 network will be blocked but another network will not be blocked. And after that I can put interface information here and IP access group 1 inside. Like if you are blocking on your router 1 your 10 network, then this is inside. But if you are blocking like any outsider network 20, 30 or 50 on your router, then it is outside. So after implementing this, you can check show access list. Now your network 10 is not able to ping with outsiders because the packet is blocked. You can go with simulation process like this. Your packet is blocked there. It came back. Okay. Like if I will remove the access list from here, like for example I will use no access list 1 and also interface F0 by 0 no IP access group 1 in, then your packet can go outside like this and it is pinging. So if you want to block the network, then you can use this command like whole network. If you want to block only one PC, then what you can use, like for example you want to block you want to block only 10.0.0.1 with everyone. So you have to use access list 1 deny host 10.0.0.1 only. Rest other commands that you have used here, access list 1 permit any, interface f0 by 0, they remains the same. Access list 1 permit any and interface f0 by 0 IP access group 1 in. Now your 10.0.0.1 is blocked with everyone, okay, but your 10.0.0.2 can ping outside. So you can block specific host with this command, okay. So if you want to again remove access list, no IP access group and no access list 1. But there is one problem in standard access list that you are not able to complete block your host with host or your network with specific network. So that's why I have to use in this extended ACL. Like for example, I am taking one example in which I want to block 10 whole network of 10 with specifically 20.0.0.1 and 30.0.0.1. Rest other network should be permitted. Only 10.0 network 0.0.0 network should not ping with 20.0.0.1 and 30.0.0.1 like these pieces. So this is called network to host blocking. So what I have to do, I have to use extended access list. Access list 100 deny IP. Now network 10.0.0.0.0.7 should be blocked with. Now in extended access list I can use destination also, host 20.0.0.1. So I have done with one deny command. In another command, deny command, I have to put 30.0.0.1 also. Like 10.0.0.0 should be blocked with this host, 10.0.0.0 block should be with this host. Access list 100 permit IP any for two time is, one is for source and one is for destination. 100 in. Now what will be the effect of this extended access list? Now 10.0.0 network is blocked with 21 30.0.0.1, but rest other PCs can ping with that network. Successful. Okay. It is blocked with 20.0.0.1, but it is pinging with 20.0.0.2. It is blocked with 30.0.0.1. Okay. It is pinged with 30.0.0.2. If you don't want to check like graphical view, you can go for this. Like if you will ping with 20.0.0.1, they will tell you destination host unreachable. But if you will ping with 20.0.0.2, they will ping. So this is the benefit of extended access list. Now we will take one more example. First I will know the command. No access list 100. Sorry for that. Now for example, you want to block your 10.0.0.1 with 20.0.0.1 and 10.0.0.2 with 10.0.0.2 with 20.0.0.2. Multiple blocking like. So what you can do, access list 100 deny IP host, your 10.0.0.1 should be blocked with 20.0.0.1 and your 10.0.0.2 should be blocked with 20.0.0.2. Now after that, the same commands, access list 100 permit IP any and interface FH0 by 0 IP access group 100 inside. Now your 10.0.0.1 is blocked with 20.0.0.1 and 10.0.0.2 blocked with 20.0.0.2, but 10.0.0.1 pinging with 20.0.0.2 and 20.0.0.1 ping with 10.0.0.2 sorry. So you can go for specific blocking in extended access control list. Okay, thank you so much. Hello friends, Today we are going to discuss about layer 2 securities. Like layer 2 security features, we need to discuss about it. So in layer 2 security features, we know that we have so many things like we can put port security over network. We can go for DHCP snooping if any DHCP spoofing attack is there. We can go for DAI dynamic ARP inspection in this. Okay. So what is DHCP snooping actually? DHCP snooping is a security features that acts like a firewall. Firewall is a security device. It is act like a firewall between untrusted host and trusted DHCP servers. Okay, the feature performs the activities like it validates DHCP messages, receives from untrusted sources, and filter out invalid messages. Okay, so this is also used for some features. And besides this, dynamic ARP inspection is a security features that validates ARP, address resolution protocol. Address resolution protocol is basically used for IP to MAC address, like you can resolving process. Like DAI dynamic ARP inspection allow a network administrator to intercept, log and discard the ARP packets with invalid MAC address to IP address binding. So this capability protects the network from certain man-in-middle attack. Okay, so it is used with the process of man-in-middle attack. And after that, port security is the feature in which you can provide security to specific LAN user also. Okay, so for this, okay, let's start with some practical on Cisco packet tracer. We'll do the practical on Cisco packet tracer here. So in Cisco packet tracer, we can go for, where is my Cisco packet tracer? Okay, we have to set up here one switch and PCs 1, 2, 3. Okay, so I'm providing IP address to PCs 20.0.0.1, 20.0.0.2, sorry, 20.0.0.2 and 20.0.0.3. Now they are pinging with each other, and when they will ping with each other, they will provide their MAC address to switch. Now you can check. Show MAC address table. So dynamically MAC address of every PC is like installed in MAC table of switch. So if any other PC is using there, then their MAC address comes with this. Now what port security will do? Now port security will like assigned static MAC instead of dynamic. So if for example this is XYZ PC, so I want to assign its MAC address permanently to this PC. So this cable can be used by this XYZ PC only. No other user from another network or with the same network is not able to access from that specific port. So we have three types of port security violations. Like we can use protect, we can use restrict, and we can go for shutdown. But most of the time in company we use only protect command, and 80% we are using protect. Then mostly the rest part we go for restrict configuration. We don't use shutdown because when we use violation shutdown in port security, then the port is totally shut down. So what I will do, I will put protect violation on XYZ, restrict on PC1, and shut down on PC number 2. So let's start with the configuration. So I have to go on this. What I will do, I will do the command interface first F0 by 1, F01 switch port mode access switch port security, switch port security. Now I have to mention how many maximum MAC address I want to implement. So maximum MAC address should be one only, but you can put 1 to 132 MAC address. So switch port security, MAC address I have to say here. Sorry, MAC address I have to set here. Either I can go with manual MAC address or I can use sticky command. Sticky command is used for dynamically, it will check the MAC address and installed in MAC table statically. And at last, switch port security violation protect. So in this I have used protect violation. So with the help of protect violation, I will copy this and I will put it on notepad for you. This is my command that I have used. So when you are going to implement, like instead of protect, you are going to implement on F0/2. What you can do? You can do on F0/2, commands are same, but restrict should be there, the violation. Rest all things should be same. Okay, so I'm putting this thing. And on next time on F0/3, I want to put shutdown. So within this video, I can show you to all the violation that can be used in security. So at F0/3, I have put shutdown. Rest all other commands are same. Okay. So show port security. When you will go for port security, now you can check here. This one. F0/1 is configured with protect. F0/2 is configured with restrict. F0/3 is configured with shutdown. Like all three PCs are configured. Now if you will ping XYZ to PC1, then successful. PC1 to PC successful, but show MAC address table provides you static entry. So after they are providing static entry to you. Now if anybody use protected PC with another PC, like this is also 20004, it is not able to ping. But if this cable is used by XYZ, then XYZ can ping. Now what is the difference between protect and restrict? If you use protect, then there is no problem. But if you will use restrict here, okay, like restrict cables you are using, then you are not able to ping to this. Okay, there is no pinging, but when you will check show port security, you can check security violations can be counted. So security violations can be counted here, but if you use this cable into again this PC1, then they are able to ping. But what is the drawback of shutdown command? Shutdown commands, then you can use shutdown. If you are pinging with any PC, your port will be shut down. So that's why I was saying that protect violation was best, and restrict is also best. You can check the security violations in this, but shutdown is not good, because in shutdown now I have to put error disable recovery mode, and after that I have to manually change all the configuration on our switch. So this is all about layer 2 security. Thank you. Hello guys. In this video, we are going to discuss about how network impact by automation and programmability. Like how automation impact on networking. Like you are watching in this design, we have connected our routers and big data server, real server, honeypots, and Python programmings are also used in this. Okay, like why we use this concept? Because we have to detect hacker traffic and we have to launch Python script, redirect flow. So basically, what is the impact of automation on network? So let's discuss about this concept. Okay, so first of all, we have to discuss about like network world is developing rapidly. Okay, like with these development, network requirements has increased and new methodologies are also developed to overcome this improvement. Okay, so we have so many improvement in our network, so that's why we have to work on that. So one of the technology that helps network world about network automation. Network automation, I have already told you that Python is added in our network. With network automation, what are the impact? In network automations, we have used activities like network management, testing, deployment, configuring and various network operations. Okay, with the help of this network automation technique, what are the benefit? We have reduced our operation cost. Okay, so our operation cost is reduced, our times is higher time up. After that, with the help of automation, our errors are low, like lower errors, our staff is effective, our network control is better, our business agility is increased. Okay, so with the vision of network automation, you can develop new products and services that can improve your business agility and market share also. Okay, so this is the impact of network automation on our network. Now, we have to also discuss about like what are the basic difference between traditional networks and controller based networking. Like what are the difference that we have to work on that. So I have some difference here, like we have to work on the criteria like about traditional network as well as our SDN, software defined networking. Okay, so in traditional network and SDN, what are the difference and what is the approach used by the network authorities? The approaches are like network management. Okay, so we have so many criteria: network management, global network view, maintenance cost. Okay, if we talk about network management, then in traditional network it is difficult because changes are implemented separately for each device. I have my 3 labs and in 3 labs we have so many devices. So for traditional network, management is different. Global network view is also difficult in traditional network. Maintenance cost is very high. Like if we have to update our network, then it will take months. Like we don't have controller utilization, we don't have importance of authenticity, integrity and consistency of controller. Okay, so this thing is common in traditional and SDN, like integrity and consistency, and availability of controller is not relevant and resource utilization is less. But in software defined networking, network management is very easy. Global network view is with the controller, maintenance cost is very less and time required for updates quite easy. Why? Because we have central controller in this. Okay, controller utilization is important, authenticity and integrity part is same in traditional and SDN. Okay, but availability of controller is very important in SDN. Okay, so now resource utilization is also high. So now we have to say like SDN is far better than our traditional network. So this is the great impact of automation on our network. Okay, so thank you so much about this topic. In our next video we will discuss about so many automation topics. Thank you. Hello everyone. In our last video we have discussed about automation and programmability, and same as I am continuing about the topic, and in this topic we have to discuss about SDN, like what is software defined networking and what is control and data planes work. Okay, so the first of all, you are watching the screen. in which you have seen management plane, control plane and data plane. Like this is the example of controller based and software defined architecture, in which we have separation of control plane and data plane, as well as we have northbound and southbound APIs. But first of all, what is SDN? Software defined networks. Software defined networks refers to the concept of separating this control plane and data plane. Okay, it is in the network, and the separation of these layers enables the external management and control of distributed lower layers transport functionalities. Okay, now you can check like how it will work. Like you can check on management plane what is the work, like Telnet, SSH, SNMP, Syslog. Like you want to access one network, you want to manage or configure. So with the help of Telnet, SSH or SNMP, you can remotely device connectivity. Okay. And after that, on control plane, you can check the networking, the routing protocol OSPF is used. And on data plane, what is the work? IPv4 packets are connecting with each other. Like, sorry. So we have to make design first. When we have to work on data plane, our IP addressing will be there, and in our control plane, our routing process will be there, and on management plane, you will work on Telnet, SSH, SNMP, Simple Network Management Protocol, and Syslog. So this is about software defined networking. Thank you so much. Hello everyone. In this video, we will discuss about REST API and DNS Center. As you are watching in the diagram, that we have DNS Center and REST APIs are used with script and graphical user interface. In the below section, you have seen Telnet, SSH and SNMP, as well as you are watching NetConf and RESTConf. So let's discuss about Cisco DNA first. Okay, Cisco DNA. Okay, Cisco DNA Center exists as a software application that Cisco delivered pre-installed on a Cisco DNA Center appliance. Okay, so the software follows the same general controller architecture concept. In this center includes a northbound REST API and along with the series of southbound API. So we have both the APIs are connected with each other here. For most of us, the northbound API matters the most because of the user of the SDA network. You interact with SDA using Cisco DNA Center's northbound REST APIs of the GUI interface. Okay, and it supports several southbound APIs so that controller can communicate with the device that it manages. You can think of these two categories. We have Telnet, SSH and Simple Network Management Protocol. These are the protocol to support traditional networking device. These are the software versions. And NetConf and RESTConf are to support recent networking device. Okay, so these are known as Cisco DNA centers. Like this CCNA is based on DNA centers. Like this is based on scalable groups also. Yes, we have some issues in our traditional IP based security, because in traditional IP based security like IP ACL we were used in the first version of ACL with the 3 access control entries, access list commands you are used. The engineer added 2 more lines to the ACLs. Okay, in access list. This is about the traditional IP based security. But in real new controller based networking, like controller based networking SDN, we have extra security feature in this. So we have to work on this also. And now if we are looking for REST APIs, like how they are impacting. So RESTful services, we have to know about these services. RESTful services. Now, first of all, we need to know about what are the RESTful services which have a uniform interface, because the client must track the states of the session and send request containing all the information required to process such a request. Okay, the server must not store user session context information. The server which is using in this must state whether the information can be cached on the client or not. So these are the characteristics of REST based APIs. Thank you so much.